One, uh, thank you so much for creating time to sign up and getting to take part in this webinar session. And the Microsoft student partner. Sorry for that. So let's get to start again. So to sign up and getting to take part in this webinar session, the Microsoft student partner and the developer student club, University of Nairobi, welcomes you to this live stream webinar event that's titled Machine Learning Introduction. This will be a highly impactful and information dense and a quite engaging Q&A webinar session, whereby we'll be getting to hear more, getting to learn, and getting to have burning questions answered by our talent pool data professionals from Kenya and across the globe. So from the Microsoft Student Partner and the Developer Student Club of Nairobi, Kenya, welcome everyone to the Deep Learning.ai community. And more so to that, welcome you to this live stream webinar. We do greatly acknowledge your online presence, you creating time to being in for this session. We appreciate you and we look forward to your participation, questions, the interactions that we're going to have during this session. Once again, welcome to the Deep Learning.ai community. You're saying, get to grab some coffee, or maybe some coke, or if maybe it's a bit cold where you are, get something that will keep you warm. Make yourself comfortable for the next 4.5 hours because we will be actively engaging, having discussions, having more burning questions answered in this unique and one of its kind, highly interactive Q&A webinar session. We do understand the current crisis and the pandemic that we are facing across the globe. We're all grateful to this amazing team that despite the challenges that we've been able to keep the conversation going and ensure that we're able to handle and get to hear from these data professionals. How do you get to handle the pain points of machine learning introduction? How do you get to move from just building models to building significant data products and solutions? So we're so grateful to have you, and we do appreciate your online presence. And are you ready? Yes. Welcome for this Pi and AI webinar session. This session, this event would not have been able to stage this session without this amazing team. That is the webcasting team that has been actively involved in the organizing, in the planning and preparing, and now getting to execute this session to ensure that despite the challenges that we're going through, we're able to continue with the conversation, get to hear from more speakers, and get to learn from each other as we get to share our experiences. And in the team, we have Daisy Kabi from the Microsoft Student Partner. We have Lydia Gadoni from ICT Authority. We have Gladwell Onjiku from Developer Student Club. We have Tabitha Kaviu from Developer Student Club of Nairobi. John Mbugu from Microsoft. We also have Griffin Ochieng from Deep Learning.ai Ambassador to Kenya. We also have Nicholas Musau, Deep Learning.ai Ambassador to Kenya, and myself will be taking you through this session shortly, Kennedy Wangari. So we will be getting to interact with this team in the Slack channel, in the YouTube live chat. And if you might be facing any technical hitch, any challenges, or any questions that you feel you'd like to ask, feel free to reach out to any of our members of our casting team. We will be there to actively engage with you, to help you and support you with in any technical challenge that you will be facing. So feel free to reach out. And yes, we're getting ready to hear from our panelist speakers. But we need to know, what do you expect to learn? What do you expect to hear today? So if you look at our screens, we're getting to see that one, through this webinar session that is titled Deploying AI, Machine Learning in Production, we're getting to see that we will be getting to hear an exclusive video. And in this video, we will hear an exclusive message from Dr. Andrew Ng, whom we all respect. We all know the amazing work he's done in the field of AI and tech space in general. He has inspired most of us in machine learning. And we will be getting to hear his message for us for this particular Pi and AI session. And we will be getting to hear also what does the deep learning.ai team has to say as far as deepening our competencies in machine learning and deep learning is concerned. So we'll be getting to hear shortly a video and the message that they have for us. So that is one of the things that we do expect to hear. Also, again, through the session, this is a quick early notice to each and every one of us that if you look at our screens, we're able to see that we will be receiving free coupon codes for deep learning.ai courses on Coursera. And that means that being an early notice to each and every one of us is that we shall receive a follow-up email that is next week from deep learning.ai. And this email will have guidelines on how we're going to redeem these coupon codes. And we will be able to access deep learning.ai courses on Coursera. And we all get to know the significance of this, because accessing these courses at Coursera will be able to help us to deepen our machine learning and deep learning knowledge. And again, as you're saying, despite the challenges that we're facing across the globe, we can utilize this time productively to get to learn a new skill, to get to deepen our skills. So getting to access these free coupon codes and access to the course is really, really, really an amazing thing that deep learning.ai is doing. So check out on your emails next week, you will be receiving free coupon codes. An amazing thing is that we will also be receiving a 1 month access to the newly launched AI for Medicine specialization that will be getting launched on the April 15th by the deep learning.ai team. So for all the attendees, we expect to get 1 month access to this course. We'll get to know more about it as we go through the session and hear more announcements from the deep learning.ai team. And the sweet part of the event is that we will get to hear valuable talks from our Kenyan and international speakers who will be joining us from Colombia, from San Francisco, and also Baltimore, Maryland. And they will be engaging us in question and answer webinar sessions in this topic of the day, machine learning in production. And for this session, this is where I would love us to mostly be active. Let's continue getting ourselves comfortable, because this is the backbone of this event. And this is where we'll be getting to learn a lot. And we expect to gain an in-depth understanding of how do we make informed architectural decisions on one, storage, data transfer, computation, and communication. And also to that, getting to understand what is the significance when it comes to moving our machine learning models that we build from practice to production. And we've all at some point faced the pain points in machine learning in production. They will be getting to share with us actionable tips and strategies on how do we get to address the pain points of machine learning in production, how do you address the complexity and the data pipeline concerns in the production environment. I'm so excited because through the amazing panelists that we have lined up for the day, we'll be getting to know more about them. We'll also be getting to learn from them. How do we get to, what does it take to build and deliver significant product value in production environments and building data products that positively impact our organizations and also at personal level and for our communities. So that is the backbone and the amazing Q&A session that we'll be having with the 6 speakers who will be joining us shortly. And again, as we're saying, as we gear up for this amazing Q&A session to start shortly, we're getting to introduce the Slido platform. This platform is where we would love those ideas that you have, those insights, the suggestions that you have, the questions, keep them coming through the shared Slido platform link that you can see on our screens. Keep the conversation going on YouTube live chat, the Zoom platform. We'll also be having this link shared with us on the Zoom platform and also on the YouTube live chat. Keep the questions coming. Keep your suggestions again, the insights, your experiences, and anything that you'd like our speakers to know or you'd like to share with us. Please, let's keep the conversation going. We want this to be a highly interactive, engaging, and lively conversation. We'd love to hear from you. Get to share with us. What do you anticipate to learn today? What are your learning objectives? What are your thoughts? What ideas do you have? And what interests you maybe on the topic of the day that we've just outlined on what you expect to learn today on machine learning in production? Keep the conversation going through the link on our screens that will also be shared on YouTube, live chat, and also on Zoom. And also get to share something about yourself. Let us know, where are you following the conversation from? Where is your location? The country that you're tuning in? Do share something with us about yourself. And maybe you can also, if you've had experiences shipping and building machine learning solutions and shipping them to production. Again, we mentioned that part of what we expect for this session is having a conversation where we will be able to, a platform to engage with each other. So you get to share with us your experiences. How do you handle the pain points and the intricacies of machine learning in production in your organization or at personal level? And with that, the last key thing that we expect to benefit from during this session is that we will have a full hour at the end of this webinar session after we've heard from an amazing pool of speakers, after we've had burning questions answered, after we've engaged with each other. We're going to have a full hour at the end of the session that I would encourage us to utilize productively with this amazing global community of learners who are joining us even now for the meeting. We do acknowledge you, we do appreciate you. So we will have a full hour at the end of the session to get to e-meet, to get to e-connect, and getting to share our experiences. So let's also keep the conversation going and also make productive use of this that 1 hour session. And aside from getting to interact and pushing our ideas, our suggestions, what we expect to learn today through the Slido platform, the questions to our speakers, and getting to share our experiences. Let us also get to engage interact and steer these conversations. I'm also getting to share the proceedings of these events on social media, be it on Twitter, be it on LinkedIn. Keep sharing the proceedings of these events on social media, on Twitter, on LinkedIn. And remember, there's a sweet part of it. We have an awesome branded gift from deeplearning.ai for the most active and engaging person on social media. So you never know, you might be the person whom the team, as from next week, you will get to be shipped an awesome gift from deeplearning.ai. So let's keep the conversation going. Let's engage. Let's share our ideas. Let's get to share what do you expect to learn today. Let us know where you're tweeting from. What would you like to hear more from our speakers? What would you like to hear from Andrew NG as he gets to speak to us shortly? What more would you love to hear in forthcoming engagements or from deeplearning.ai? So those are the hashtags on our screens. Tag hashtag Pioneer Nairobi, hashtag deeplearner, hashtag deeplearning, hashtag Pioneer. Get to tag deeplearning.ai, DACUN, at MSPUN, Andrew NG. So let's keep the conversation going on the Slido platform. You're getting the link on our YouTube and also on Zoom platform. And also let's scale the conversation and the proceedings of these events on social media. I hope we're getting ready and gearing ourselves for the Q&A about to start shortly. And I did mention earlier that we're privileged that we will be able to receive a 1-month access to this amazing and forthcoming specialization to get to deepen our machine learning competencies and handle in medicine field. And at this point, I would like to extend a warm invitation to each and every one of us to sign up for the Pioneer event on our screens. Let's get to sign up. We will be having the amazing Andrew NG being one of the moderators for the session amongst the other speakers. Let's get to sign up so that even as you get to receive the access to this course, we will be getting to hear more from him. And at this point, we will gear ourselves to hear what is the announcement that the deeplearning.ai team has on this new specialization and what more other announcements that we will be having. So let's get ready to hear, to have a short video being played for us. And I believe this will trigger excitement on why we would all, it would be best for us to delve and learn more on this AI for medicine specialization, also looking at the current pandemic and the crisis we're in across the globe, and with the immense potential that artificial intelligence can really solve for us. So let's get to hear the video and what Andrew has to say. Thank you.
This is a 3-course specialization, and in the first course, you learn about machine learning models for diagnosis.
You will build an algorithm that will look at a chest X-ray and determine whether it contains disease. You'll also build another algorithm that will look at brain MRIs and identify the location of tumors in those brain MRIs.
The second course will be on predicting the future health of the patient, which is called prognosis.
You will learn how to work with structured data. So let's say you have a patient's lab values and their demographics and use those to predict the risk of an event, such as their risk of death or their risk of a heart attack.
Finally, in the third course, you learn about AI for treatment, that is, for the process of medical care, and also for information extraction, getting information out of medical text.
In course 3, you will learn how to use machine learning models to be able to estimate what the effect of a particular treatment would be on a patient. You'll also learn about the application of AI to text for particular tasks like question answering and for extracting labels from radiology reports.
So, lots of important topics to cover. I hope you're as excited as I am.
Let's get started.
Great. So I believe we all excited, and as Dr. Andrew NG has mentioned, let's get started on 15th. And sorry for the slight hiccup. Next, I did promise us that we're going to have an exclusive message for us by Dr. Andrew NG. We all respect him. We all know the amazing work that he's been doing as an AI researcher, as an educator, amazing work at Baidu, at Coursera, and taking active roles on the innovation space. His great work founding the deep learning.ai that is powering this event that we are at, Landing AI, amongst other amazing work that he's been doing in the AI field. So at this particular moment, we're going to hear the exclusive message from Dr. Andrew NG. We'll be getting to hear what special message that he has for us for these Pi and AI webinars.
Hello, deep learners. I'm Andrew Ng, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pi and AI what you do at deeplearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pi and AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new. Organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
Yep, that's really important work. Well, it's nice chatting. And now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pi and AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project. Or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot both from the talks and from each other. And once again, welcome to the deeplearning.ai community. This is a 3-course specialization, and in the first course, you learn about building machine learning models for diagnosis.
You will build an algorithm that will look at a chest x-ray and determine whether it contains disease. You'll also build another algorithm that will look at brain MRIs and identify the location of tumors in those brain MRIs.
The second course will be on predicting the future health of a patient, which is called prognosis.
You will learn how to work with structured data. So let's say you have a patient's lab values and their demographics and use those to predict the risk of an event, such as their risk of death or their risk of a heart attack.
Finally, in the third course, you learn about AI for treatment, that is, for the process of medical care, and also for information extraction, getting information out of medical text.
In course 3, you will learn how to use machine learning models to be able to estimate what the effect of a particular treatment would be on a patient. You'll also learn about the application of AI to text for particular tasks like question answering and for extracting labels from radiology reports.
So, lots of important topics to cover. I hope you're as excited as I am.
Let's get started.
At this point, as I did earlier mention that Andrew and G has been one of the amazing AI and also in the tech space mastermind who's been able to deliver a lot in terms of in the technology space and also in the AI field in particular, from founding Deep Learning.ai, Landing AI, co-founding Coursera, and through Deep Learning.ai. That's where most of us have been able to get the inspiration and get to kickstart our learning trajectories in machine learning. And Deep Learning.ai, part of his amazing work, he built it because he wanted to further the AI education being accessible to everyone. And as part of that, that's where we're able to access the Deep Learning.ai courses. And remember, we did mention that each and every one of us will be receiving next week free coupon codes to access courses. And also, we did mention that we will be having an exclusive 1-month access to the AI for medicine specialization. We've also been able to hear the announcement and a sneak peek of what will be coming in that specialization of courses. And aside from that, in efforts towards accelerating AI education being accessible to everyone, Dr. Andrew Ng founded the Pi and AI meetups, like the one we're in today. And we're getting to see on our screens that the session that we're in today is an online session, bearing in mind the current pandemic and the crisis. Despite that, we're still able to converge together and hold friendly format and have a session where we can be able to engage and bring this uh, uh, session where we'll be able to hold conversation amongst ourselves, get to share our experiences, get to hear from our speakers for the day. Today we got really amazing, informative content for us. So get ready, and we're very sorry for the few hiccups at the start. So that is where Pioneer mission comes in, and we will be getting to also have the few minutes to get to engage and interact with each other. So we all saying that get to have your burning questions ready, and my hope and trust is that by the end of this webinar session, we will be fully equipped to cultivate product development mindsets and being able to build innovative data products. And more to that, we will be able to know how do you get to handle the pain points of machine learning in production and build solutions that positively impact our societies and also get to drive business value. And without said and done, I'm hoping that as we get to gear up to start the Q&A session shortly, we did inform you that keep your questions coming, your suggestions coming through, and we will get to have an amazing pool of speakers who will be joining us in a few minutes from now. And to be able for us as the organizing team to manage your expectations accordingly, we did uh, filter and consolidate the questions that you had shared with us. And from that, we were able to pick the burning questions that you feel that our speakers would maybe get to come and share with us more. So we will, from the feedback that we were able to receive from each and every one of us, we will be seeking to have that in-depth understanding and getting to have answers from an amazing pool of speakers. And so that's why we're saying, have your burning questions ready. They're those questions that you shared with us. Yes, our speakers will exhaustively get to answer us. We also have other questions that we are keeping them coming through the Slido platform. They will all get to be able to answer us. We'll be able to have an interactive session. And we will also have a short Q&A after every speaker. We've been able to, looking at our screens, you're able to see we have 6 speakers. And after every speaker's short session, we will be able to have a short Q&A, whereby the questions that we're posting on Slido platform, we will be able to, as we've been directed, the top most voted questions, we will be getting to hear their responses and also their insights and their input on the same. So keep the questions coming. And at this moment, I would like to get ourselves ready, get yourself comfortable. We're almost done fixing the few issues that we've had at the start. Keep your comments, keep your suggestions. Let's engage on Slido. Let's keep the conversation going on Twitter, on LinkedIn. Remember, we have an amazing branded deep learning.ai gift. You might be the person who will, at the end of the day, end with a gift, and also having learned a lot from our speakers. So at this point, I would like us to start getting ourselves ready. You can get a pen and a paper or something. If you have a question also, keep pushing them. And we're now getting to the Q&A session. As you can see on our screens, we have 6 speakers. We will Q&A. We'll be getting to have the beforehand questions, as you mentioned, the questions that you did share with us beforehand, getting to hear what our speakers have in store for us. And as we go on with the conversation, more developing questions, keep them coming through the Slido platform. So at this point, I'd like to invite Griffin to take over and guide us through the next session of the panelists, the Q&A webinar session. Griffin.
Greetings, everyone. I'm Griffin Ochingwa, and I'm part of the webcasting team here today. I'll be taking you through the Q&A session, and I hope you guys are comfortable wherever you are. Get your notebooks handy so that we can be ready to kick off the Q&A sessions. And so to start us off on board, we'll be having Chris Orwa. And Chris Orwa is the lead data scientist at I&M Bank, Kenya. He also writes for the Daily Nation, a Kenyan newspaper, as a data journalist. And he has a wealth of experience of over 8 years focusing on computational techniques for unstructured data. He is a passionate blogger and writes about data science articles on his personal blog, that is blackorwa.com. And Mr. Orwa is also actively involved in strengthening and shaping up the Kenyan AI economy through data science workshops, mentorships, and providing sound and professional guidance. Chris Orwa is a huge sucker for World War II books, and for that matter, he has a huge library at his place. And in his free time, he also collects vinyls and has love for comic books. So, Mr. Chris, wherever you are, if you can hear me, kindly say Jambo.
Jambo.
Welcome on board, Mr. Chris. And so you will be engaging us and responding to your questions through visuals. I hope you're set from your side. You comfortable?
Yes, I am.
Okay, so through the first question, Chris, could you tell us in your own words what deploying a machine learning model means, and what are some of the factors that an ML practitioner needs to consider when moving an ML model from practice to production?
Okay, so just allow me to share this first. Okay, so at least for the past 9 years or so, I've worked for different companies, mostly building machine learning models, doing analysis, but also figuring out how to put them into production. So allow me to quickly show this visual. It has a lot of things, but basically where does your modeling actually play the role? You can see on the purple part of it, there's a whole other business understanding, data acquisition, deployment, modeling, and then deploying it into the production environment. So from my own experience, if I go back here, these are some of the factors that have come into play while deploying machine learning models. Number one is customers or users of your system. When you work for a company that has scale, that has millions of customers, and you need to predict something about those particular customers, that really affects how you're going to put your model into production. Example, let's say you work for a bank and you need to every month to predict what products you need to sell to customers or which customers are likely to leave the bank. It means you have 1 month, you run your model at the end of the month, you make the prediction, then you push those into the sales team, to engage with the customers. You have a less problem. But if you have, which is not connected to the frequency part, if you have, let's say, your Google, you have hundreds of millions of customers, and you have to score all those customers, and you have to score them every day, then you realize scale, which is how many customers you have, how frequent you have to do the predictions. Highly, I call it becomes a problem. Problem one, if you work for, let's say, a company that needs to make predictions every day, you're an e-commerce company, a user visits your website, and you need to show them something different every day. Hello?
Yes, Chris, can hear you.
Yes. So those two things, you have 100 million customers, you have to score them daily because the behaviors are changing every day. They visit this page, they bought this product, so you have to change or update a new predictions for them. Scale and frequency, that will definitely becomes an issue when you're deploying. Another thing that became from my experience is what I call permission accessing data. Most of the time, if you're working for a business that has multiple systems, you have to get billing data, you have to get access, you have to know the customer contact at the contact center, and you're doing real-time predictions, and you need to get data from all these systems. And you realize, and if you work for an organization that has permissioning, like there's a tiered access to different databases, and then you're putting this model into production mode. One of the things that from a cybersecurity team, we'll be told you can't access all the system anytime, because if someone hacks your ML system and find config files or passwords, they can actually access the other data. So it becomes a problem when you're doing real-time predictions and you have to get access to all this data and then have your features and then do the prediction. The third has been, the fourth one, sorry, has been feature engineering. So remember, most of the time, the variables you use for predictions are not the raw data as received. You're always, changing them, manipulating them, creating new features. So then again, you have a very large database. You're, collecting so many variables, and then in between, you're doing your feature engineering. So when this mostly affects real-time predictions, and you ATM, you bought something, you went and ate in a restaurant. I need to pick all that data and then combine what is your average, how far do you move from home to eat, for example. I compute that. Is this a new restaurant that you've never gone to? Calculate the distance between what I know as your home and the distance between these new restaurants that you've just had a meal. So that, and also those kind of features that you're trying to build, it means that there's always a middleware that's always crunching these new variables. And then the problem is, by the time you're getting to predict, maybe it's too late, because you're in a restaurant, you're in a Java restaurant, for example. I want to know you're the restaurants. I want to make a prediction while you're in that particular restaurant and send an SMS to you. But because of all this new feature engineering part, it delays, and maybe you're the restaurant for, let's say, 30 minutes maximum in that case. So that really affects putting your models into production. And then continuous integration is you're always building new parts to your models. And from my experience, the modeling part is the easy part. Trying to have other parts connected to that model, because one is the feature engineering part, others is configs and files that connect to the DB, and others are like, most of the time you have all this support, I call it a support system for your model, right? And they need to be integrated. Sometimes they break the code or something doesn't work. So you always have to be very careful about your continuous integration and what new things you're building into the model. Great. So I guess, yeah.
Okay.
So that's the first question?
Yep. And thanks so much, Chris, for shedding light on that. And I hope you have it there, guys. You need to consider scale, frequency, most importantly, permissions, so that you don't have trouble with people getting to access and tamper with your data. And also consider continuous integration. And so, Chris, what are some of the computer science, software engineering practices and development tactics that an ML engineer should implement when handling ML operations?
So when it comes to especially when it comes to production and so building the model first and then production, half of that is almost software engineering concepts and principles that you have to take into consideration. You're pulling data from a DB, so you need to know, am I on a structured DB? Am I on a no structured DB? Which fields do I have? What's the data type in those particular models? The algorithms don't take categorical variables, others only take numerical variables. So when you're preparing your data, and you need the software engineering / computer science concepts come very useful, because like, okay, if you're in Python, if you're in R, or the data types that you need. But also what I found very important, oh, sorry about that, the plane. Oh, now everyone knows where. Now everyone knows where I live because of the plane. Anyway, so one of the most important parts I figured out is how to make your deployments efficient, running in the least amount of time. So if you look at all those sorting algorithms, different ways of accessing data, that's the computer science part that I've applied the most in the modeling phase, because you want to skip certain things. You want to arrange data in a different way, which data types will be used, whether it's a linked list, and etc. I'm going to use loops and etc. That's where you need a lot of that part. Once you've modeled it and now it goes into production, then it's DevOps that takes a lot of that work. What server size do you need? How are you going to access? Is the DB indexed for quicker access to the DB? Which indexing algorithms should I use? Which ones are faster? Which one are implemented in different DBs for that? So you learn about those. Just for me, computer science and the greatest contribution of computer science, say from the algorithms, is efficiencies. How do you traverse trees? How is the fastest way to arrange this data so that you can access it very fast? So from my experience and how I've used computer science concepts, it has been mostly on efficiencies.
So would you agree that practices like unit testing really make sense in the context of ML production?
Yeah. So if you look at a unit test and the different types of tests that get done, so unit is mostly for software development, right? Everyone is developing different components. You want to ensure that these components gel very well, bugs are smoothened out, and everything runs, right? So,
right.
And these are the three major things that you undertake in a unit test, right? Mm-hmm. Most people don't need acceptance testing. Most of the time, the system testing will be handled by a software engineer or DevOps. But when it comes to integration, because you're building your model and you're integrating it into the system, you're trying to make it connect. Because the output, if you look at this tree here, at the end here where you have deployment and you have customer acceptance, your model is connecting to another system. It could be a sales system, it could be an SMS system, it could be an email system, so that it can connect to the customer in that case. So at that point, you're integrating your code, your models, and etc. into that system. That's where the integration testing is needed. So for unit tests, only this component of integration testing that's needed. Once that is fulfilled, you can skip the rest of the two tests that you do in unit tests.
All right. So there you have it, guys. Now you know that half of ML production is basically software engineering. Now, Chris, can you share with us what new tools and frameworks, also architectures that you'd recommend that our online audience today might go and explore, tools that will help them scale data science operations and make model deployment much easier?
Okay, I'll talk about them, and then I'll put most of the links here. So if you look at the process that you normally use for building a model and putting it into production, so you usually start with the code and you're building a model. Once that works, then the natural tool to push that is GitHub. So you push your code plus the model into GitHub, and from there, one of the major tools that I've been using is like Docker. Docker is like a very good virtualization tool that allows you to create a virtual environment. The reason for using Docker, and as opposed to other system, is if you have a server, a Linux server, and you want to quickly, something that's gone down, and to quickly pull the code, run the model again, then you have to set up a server. You have to install all these dependencies for that, and then you may not have enough time to do that, or the business might suffer. So Docker quickly allows you to go to GitHub, pull the latest code plus the new model that you have if you updated it, and then executes that, and then it can automatically install all the dependencies. So it has scripts that just installs all the dependencies, files, and everything you need, and then it runs it, and boom, it starts doing the predictions, and it connects to other systems that you need that. So Docker has been very useful for that. And second on all the continuous integration tools that are there, there is Circle CI, there's Kubernetes, and if you do ML on scale, you cannot avoid Docker. Okay, you can avoid Docker if you want to, but any continuous integration tool, you cannot avoid them, because pulling one having one file that you pull in, and then that's your training set. Do a training, create your model, and then do some prediction, and then push those prediction to another system. That's an easy thing to do. But ensuring that gets done for 1,000 customers or 100,000 customers every day or every minute, then you're working like 10 data scientists, and someone just changed one thing, and like, how do you ensure that gets into the model, gets updated, gets tested, and gets integrated? You need continuous integration tools. So you can also check Jenkins, depending on the environment you work in. All of them have advantages and disadvantages. But for me, I've used Circle CI, I've used Docker, GitHub. Those are the tools for productions that I need. I can see everything. I can run anything at any time. I can track almost everything from the production to where the data scientists have one playfield for that.
All right. So I hope our audience are quite satisfied with what you're sharing. And guys, just a reminder, the tools he talked about are GitHub, Docker, and Circle CI for continuous integration, and Docker for virtualization, pulling code, and installing dependencies right away. So Chris, to the final question for now. Why is it that machine learning teams have a hard time setting goals and expectations? And what best practices would you recommend to managing expectations and handling people and the technologies that are involved?
It's two parts. So the first part, expectation. Most of the time you're experimenting, right? And even apart from the experimenting, you cannot exactly give a timeline that if you go back, when you're working on an operational role, like I need to sell, you're given credit cards, you need to sell these credit cards, or you have 5 cars, go sell those cars. That's not very operational, and you can say, I sold this, I went to this place, I did A, B, C, D, and I sold this or I didn't sell that, right? So in a business environment, that's what they're used to. And if you ask as a machine learning engineer, okay, I need you to tell me the number of customers you're likely to buy this red car, for example. And then you realize, like, okay, I don't know what I'm going to do. I'm going to pick data about where they went to, or what food they eat, etc., and use that for the prediction. And you iterate through different variables, trying to figure out what has a very good predictive value. That's the place where it creates uncertainty in the business. You really don't know right? And that creates the problem of setting that goal. I'm going to do this in this time. Another problem that depends on whether you have experience or not is knowing what can be predicted and what can't, right? So if you've worked on a use case before, you can easily say, I can predict this. But when you have a new use case, sometimes depending on what you've done and your understanding and your skill set, you might go into a use case that you can actually predict that, and then you only realize that after wasting a lot of time. Connecting to stakeholders, as a machine learning engineer, your output is maybe like a customer ID and a probability of them buying something or exhibiting a certain behavior or doing whatever you're trying to predict. Maybe for a business that seems like voodoo, if we may call it so, right? Because you could have just have cooked those probabilities, and the only way is to okay, let's take your predictions, let's put them to the sales channels and see if there's any outcome. And you have to wait for maybe, if your sales cycle is a month, 2 months, 6 months, you need that time to prove actually that you did a good work. So that understanding might affect that, but from just what a data scientist can do to ensure that there is no uncertainties, to explain it in a simple way possible, that this is a prediction. I'm using these variables to try and figure out if this person will do X. And these are the processes that we have. Without getting very technical, we might find something, we might not. We will report all our findings to whoever you connect to. So I think that is what has worked for me most of the time. But creating that understanding and creating short-term goals, not expecting hey, everyone thinks data science is gonna, do everything. It's gonna heal Corona. It's gonna change the world. There's other things to do. So creating that expectation. So if you cannot create expectation, create your own expectation, or bring people to your understanding, and that becomes the expectation. The process that you went through becomes the expectation, even if there's no output.
Okay, thank you so much, Chris. At least now we know how to strike a balance or meet the trade-offs between expectations and what really data science and ML can give out there. So at this point, we'll be taking the questions that you have been sending, questions specifically directed to Chris, and I'll hand over to my webcasting partner, Tabitha Calview, who will be able to display a couple of questions for Chris at this moment. And then after that, we'll wrap it up with Chris. And so Tabi, come in.
Okay. Thank you. Thank you so much for the wonderful session, Chris. So I'm going to project some of the questions. Let me share the screen. Questions from the audience. Give me a minute. Okay. Yeah, so among the voted questions, we have a question. When employing a data scientist, what are the skills you look at? Do you consider participation in Zindi or Kaggle competitions? Over to you, Chris.
Okay, so what do I look for if I'm hiring a data scientist? To me, based on the organization that I work for and the work that is needed at hand, one of the most is I call it analytical thinking. Right? You could, I've interacted with people from other business units that have any machine learning skill, but they can break down a problem to this, okay, this is what we want to do, this is what the customer needs, and for us to do this, we need to measure 1, 2, 3 thing, and then okay, now I don't have the coding skills to put it through, but I can break down a problem. Most of the time, that's the number one thing, personally, I look for, which is, can you think in an analytical, logical manner? Can you break down a problem? Can you understand what you're doing? Because for the most of the time, understanding what you're doing is the most important thing, even if you don't have the skills to do that. You can direct somebody okay, we're trying to predict, let's say, sales cycles for import-exportation businesses. And I need to know all the details that goes into it. What do people import? What do people export? And most of the time, as a machine learning engineer, you certainly go to the code, what's the target variable, which ML algorithm am I going to use, tune some parameters, get your accuracy right, and then boom, that's the end of it. And then you realize that something is off. Either you don't know why the ML is not doing whatever you need to do. So first of all, analytical mindset. Second is business understanding. Then we can talk about Zindi and GitHub, and then have you solved this problem before? How are you comfortable with the language? How quick are you? How quickly can you learn? So in that particular order.
Okay, thank you. So, Chris, the audience is curious. So what are the current research is being done on coronavirus for inventing medicines or any cure apart from the corona tracker in the machine learning community?
Oh, okay. Sorry. So I don't know if you're familiar. It's called the Good Judgment Project. You can check it online. They're like a prediction. It's similar to Kaggle, but it's mostly for global issues, pandemics, and stuff like that. So they have companies, institutions, governments to predict things that are important to them. And one of the predictions they had, they're trying to predict how many cases will be in a certain country within a certain time. So by the end of April, how many cases of corona would be reported for X countries. So they use that to help logistic firms and companies governments to be able to know, we expect 10,000 infections. Do you have facilities ready for this, and etc. So that's so far I've seen to help logistics planning for that. In the actual cure for corona, I haven't seen anything yet, at least to my knowledge. And I think the cure is not really what we're going for. I think it's the vaccine. And I've seen there's some malarial drugs and other drugs that are being tried out, like chloroquine and etc. So that all those tests are being done first. I've not seen any very interesting, good ML data science contribution towards that.
Okay. So another question from the audience. How should a good portfolio for a self-trained data scientist look like or have?
The more problems you solve, the better it is for you, right? It doesn't matter whether it's your own little project. It doesn't matter whether it's Zindi, Kaggle for that, or at least you attempted something. The number one question is always, have you done this before? And you can put your GitHub repo, you can answer questions on Stack Overflow, you could have your own other, all these coding platforms, but just have something that shows like, I've attempted this before. This personally what I look for. And I've written this code, I've attempted this problem set, and etc. So build, especially if you're just getting started, just have as much in your portfolio as possible. Have a wide range of problems that you've solved. You've solved a problem in the banking sector, in the telecommunication sector, in a fast-moving consumer goods sector, in a medical application. It shows that you're trying, sometimes you'll pick an idea from a different field and apply it in one field. So the more you solve problems, you get this 360 understanding of how problems get solved. And now I could say in banking, this is how they measure churn. No, in a internet company, this is how they measure churn. Maybe if we change our definition of churn here, use it as a banking example, then we will have different outcomes. So those are the kind of things that help you think better and show that you can tackle a problem in a much better way.
Okay, so one last question. How do you design a scalable data pipeline for a machine learning service in production, and which tools would you recommend?
I think one of the best tools to use is Hadoop. Right? So Hadoop allows you to store massive amounts of data in very little time. And if you're going to production and you have massive data, store your data in Hadoop. And then Spark is very good for doing very fast queries on Hadoop. So you have the combination of Hadoop and Spark, you won't have a problem, because if you use SQL, sometimes SQL you're joining tables, and one table is not indexed, and it takes so long to just gather the data you need, especially if the data you need to score upon. So Hadoop Spark will save the day for data pipelines. Hello. Hello.
Great. Chris, thank you so much for your insights and wonderful and elaborate explanations to the questions that our audience had beforehand. And I hope after these now, all of us now will be able to confidently start deploying machine learning models. And for more about Chris, look at his personal blog, blackorwa.com, and you can get to know more about him over there. And if you need some fun, maybe ask him about love comic books. So that's it for Chris, and over to the next Q&A webinar presenter. Kennedy, come in.
Hi, great. Thank you, everyone. I'm hoping that for the first session, we've been able to get to learn a lot from the first speaker. We've been able to have our questions answered. Again, we will still be having Mr. Chris Orwa with us for the session till the end. So if you might have other questions that you will get within the course of this Q&A session, feel free to also get to keep pushing them on Slido. And I believe at the end of the session, he will be in a great position to also share more insights and inputs with us. Once again, keep tweeting, keep sharing the questions, keep engaging. Let's get to know are your objectives really getting being met? Are you really enjoying the session? What is it that maybe you'd love to hear more from our speakers? So you'll get to find the Slido platform, the link that has been shared. So keep the questions coming, keep let us know what is it that you'd like to ask our speakers. So at this point, I'm going to introduce our next speaker. And our next speaker will be Mr. Sebastian Rodriguez. Mr. Sebastian Rodriguez will be joining us from Medellin, Colombia. He currently serves as a machine learning engineer at Landing AI, which is an affiliate of Deep Learning.ai, and he will get to share with us more onto the great and amazing work that he's doing. So yes, Mr. Sebastian, good morning on the other end, and welcome to this session. And if you can hear me, welcome.
Hi, Kennedy, and hi, everyone. Thank you for the invitation. I am happy to see that even though we are in times where we have difficulties gathering people for events like this, we still we still make it possible, make it happen, and I hope we can keep doing this. So I'm gonna share my screen to go through the questions you handed me beforehand, so that we can all and I can give an answers to that, and perhaps you can add more questions later. So I hope you're seeing my presentation right now. If it is not the case, please let me know. So yeah, I'm Sebastian Rodriguez. I work at Landing AI as a machine learning engineer. Okay, so about myself, I'm from Medellin, Colombia, which is right here in South America. And yeah, this is where my city is located. So about myself, I am very passionate about learning. So I constantly keep studying like everything that comes that might help me during my work or whatever I find interesting. I'm quite active in the local community, in the local machine learning community. So I organize events like this one for here in Medellin as well, or tutorials or things like that. So I always look to make a positive social impact in my local community. So that's why I sometimes work like an AI mentor for people that are just beginning their career path. And I love nature, and I care a lot about the preservation of nature. So that's like about the most relevant facts about myself. So now we can go to the topic of the presentation. I am so sorry that perhaps you will not be able to see everything because somebody's showing in the screen, but anyway, let's keep going. So first of all, why is it relevant to talk about the production setting in a machine learning workflow? So the way I see it is that we see that AI is a general purpose technology, such as the steam engine, such as electricity and internal combustion engine, computers, and the internet, and they can be applied everywhere, right? And they might give value in a lot of different sectors, right? In particular, we have here some sectors that are relevant, like there was retail, there was, oh, sorry, I cannot see properly where this is going. I don't know if we can erase this, these drawings here. Okay, that's much better. So yeah, there are a lot of different sectors in industry where AI could be applied, and all of those sectors impose some technicalities at the time of deploying. So for instance, an internet company might want to deploy some machine learning models in the browser, but for some manufacturing companies, they might want to deploy their models locally. And that has some constraints that are particular to that sector. Okay, so why is it important to deploy models? The technology by itself doesn't do any good. So what we want is AI to reduce the cost of predictions and detections, and also increase the availability. In the same way that computers reduce the cost of arithmetic and the internet reduce the cost of communications and search. Regarding the questions that you handed me before, I realized they were divided in 4 different topics, or 3 different topics, I don't remember. One of the topics was planning and evaluation. So yeah, so one of the questions was like, why do machine learning projects fail in production? So one of the ideas I have is that POC solutions, that is proof of concept solutions, are taught in control settings, right? While production settings include variable environmental conditions like lighting conditions might change. So we have like if we deploy a model in a production line for a manufacturing company, this company might move the machinery that it's operating with, and that might be more complicated that the problem they solve in the POC. So like basically some people simplify a lot the proof of concept and do not consider all these technicalities, and that is what make the problem fail in production. These answers are based on a blog post by a colleague of mine, Greg Diamonds. He works at Landing AI as well, and it's like his writing is really interesting. I recommend you to see. Anyway, let's keep going. So what's another question I had is what's particular for successful machine learning projects? Like what's the considerations that you should have? So one of them is like have a proper and very clear data acquisition strategy. So you need to plan for things like how am I going to store data that is coming every day from my production setting, let's say. All examples I mentioned are mainly from manufacturing companies because that's the main work we do at Landing AI, and that's my main experience. So yeah, we need to keep track of how are we going to acquire more data during the development of the project. So let's say you are a car manufacturer and you had some inspection points during your production line. So these inspection points will give you more data, but we need to keep track of those somehow in a way that's integrated with the whole workflow, right? So we need to have this clear. So we also need to identify project dependencies. So what might make some difficulties for the project? So as I mentioned before, moving some machinery around in a plant might change the conditions for the model, right? So you need to be aware of all those conditions that might change, and you need to keep track of them so that you can alert when the conditions for your data are switching. So that's another thing you need to consider. Also, there might be some dependencies on other models or on other parts of the plant that are not specifically considered in your inspection point. So you need to keep track of all that. This is quite an important thing to keep in mind. Is that sometimes the customer or even the team do not have an agreement on the success. Like what does it mean to have a success in a project? So that's something you need to identify really early in the development, because sometimes you like people have like unsupported expectations, and like it might lead to frustration for the whole team during the development of the project. You might need to, like, there are some projects that have some particular problems that you need to solve and that have not been solved before, but most of the time you can like solve a lot of your problem by just using things that people have already solved. So just to say an example, the data acquisition strategy, there are already some tools out there to like label the new data you have and to annotate in any way you need. So you do not need to develop everything from the start. So there are some good points where you can optimize your time and perhaps focus your effort into things that are more particular for your project. So another thing to keep in mind is that machine learning projects, like machine learning models, actually are not perfect. So it's fine if they do not reach, let's say, like 100% accuracy. What is important is that you frame your problem and you deploy your model in a context where it can deliver value. So for instance, in a production setting, you might not need to have an 100% accurate model, but you might need a model that detects every failure case. So let's go back to the example of a car manufacturing company. So a car manufacturing company have, in the end of the production line, a quality inspection point. So for them, it might be okay to double check some cars, but it might not be okay to send to a customer a car that is not right. So they might not care that much about accuracy or having a perfect metric there, but they might care about missing very few defective examples or defective cars. So they might have some metrics for this, and you can use those metrics to design, like to define what's delivering value, and not just thinking about a perfect idealized model that might never come true. Okay, especially because often these models get deployed in scenarios where human inspectors are working, and human inspectors are also not perfect, or there might not be perfect. So it's fine not if we don't have a perfect model, but a good enough model that can deliver value. It's also a good like a good thing to look for in a machine learning project. So one more thing that it's good to keep in mind is that we should have humans working together with our models. So in the example of the inspection for a car manufacturing company, you by using AI or by using a machine learning model, you could increase the availability of the predictions. Like you could work 24/7, but I would suggest also to have some human checking the predictions, perhaps not all of them, but a sample that that might represent some production. So one way to see it also is like when you have a model, you don't ship it right away and you don't trust it blindfolded. You look at it working, at the same time you have a human working with you, like in parallel. And that way you can gain trust on your model and see where it's failing in the production setting. And then you can improve from there. One other question I had was what strategies to implement in order to have consistent model performance. So the first one is, as I mentioned, like to keep humans in the loop, checking the performance of the model is not deviating for any standards we have defined before. You need to keep track of all changes in the production pipeline, in the product pipeline. So if your model has as input something that you cannot control, you should at least keep track of how that component that you are not controlling is changing. So if a previous step in the whole product pipeline changed, you need to be aware of that, and you need to react to that, because that might change the distribution of your data, for instance. So that would be the case with the lighting conditions or whatever environmental conditions you have in manufacturing company, for instance. It is good to have some version data. So you keep some data that you use in case you want to test the model. So let's say you change the model because you had new data, and then you want to make it better. It is good to have some backed data that you can test your model on, and so you can keep track of how the changes are like, if there are any changes on that. Yeah, and if the data distribution changes, then you should update your model. So it's not like you make a model and then you forget about everything. No, it's actually you need to keep track of a lot of variables in the project, and sometimes those variables or those changes might require you to update the model and train again, or just for a few iterations or something like that. Another questions were related to skills and tools for like improve the skills you have for model deployment. So I would suggest there is a course in Coursera. It's called This Way, TensorFlow Data and Deployment Specialization. It discusses things like putting models to work on the browser or on device like mobile phones, and also building ETLs for your data and like have it continuously work with your deployed models. So I would suggest to go through that specialization. I also like a lot the TensorFlow platform, and not only the TensorFlow library or framework, which helps you a lot while developing your models or training your models, but the whole ecosystem around TensorFlow, like it's called TensorFlow Extended. So you can search for it, and it includes things like data validation and transformation. It includes tools to analyze your models and serve your models. So it's quite complete and comprehensive, and I suggest you to go through that. And this one is quite relevant for me. I I would invite you to solve real world problems that you can share with the community, and go through the whole process with those projects. Like, do not only think about training a model, but also like think about how you will collect your data for your particular needs. How do you keep track of all the variables that are relevant? For instance, you might want to, like, just for fun or just for the learning experience, you might want to develop a face recognition system that you can use at home. And so I would suggest you go through the whole process of collecting data for that, developing the model for that, and then deploying the model. That will give you some skills that are really relevant for a job in machine learning. So that project can be your project, your personal project. It can be the project that a community has that you might want to help them solve. Yeah, and there are platforms for this. So you know Kaggle and you know Cindy, you mentioned before, but those platforms usually just go as far as developing the model, right? As opposed to deploying or understanding the whole context of the customer. That's quite an important skill to have, an important experience to acquire. So I would suggest you go to this platform here, which has some more comprehensive ways to get you involved in the whole process. And the last thing was related to ethics. So what's about ethics in machine learning models or interpretable machine learning and the biases a model could have. So this risk factor, like ethical problems, are risk factor for your project. So you don't want to develop a model like the whole thing and then realize that there is an ethical issue that was not solved and you cannot ship your model properly, right? So it's like something you need to discuss before you start doing anything. In the interpretable machine learning case, well, it's not always necessary, and it might mean to trade off some performance. So you might need to decide where you have a model that might predict where you have a disease or not. So you might want to say like, okay, I have this model with like 99 accuracy, but I cannot understand why the model makes some decisions. But I have this other model with 80% accuracy, and I can understand why the model made the decisions. So you need to trade off what's more important to your case, because you need to realize that it's not possible to have the best of both worlds always. So yeah, you need to trade some things off. And the biases for machine learning model might arise from the team building the model, right? Because they don't care a lot about some features that might be some conflicting for other people. You need to be aware of the features you choose to develop your model, because sometimes those features are the problem. Like those features might include the bias. And you need to keep track of model performance on a specific feature value. So for instance, you need to keep track that the mistakes the model you're making, like the mistakes that the model is making do not favor any, let's say, gender. So if we are talking about gender for a machine learning bias perspective, you want a model that makes the same kind of mistakes regardless of whether, regardless of any particular gender you're using. So you need to evaluate that kind of thing to check for biases in your model. Yeah, I guess, I don't know if we have time for QA right now. I guess I took up a lot of time. I don't know, Kennedy, what do you think?
Hi, Mr. Sebastian, and to everyone. Can you hear me?
Yes.
Yes. I believe at this point we've had a couple of questions from our attendees, and we will invite Tabby to visualize the dashboards and get to share with us the questions that have been coming through. So Tabby, take us through the questions that our attendees have for our speaker. Tabby. Okay. As we get to wait for Tabby to share the questions with us, I believe also at a personal level, I also do have a couple of questions that I would also like to ask, but I'll give Tabby a few minutes to get to ask her questions. So Tabby, if you can hear me. Tabby.
Okay, thank you so much for the informative session. We have a couple of questions from the audience that you could answer. Right, so let me just take you through them. Okay, I'm unable to share my screen. So give me a minute to access the question now that I'm not able to share my screen. A minute. Yeah. So as I wait, thank you so much for the feedback we are getting from you guys. The questions are coming along so well. Thank you so much for the active participation, and we will urge you to continue doing that. Yeah, and also for participating in the poll. I'll be giving analytics for the polls later on when we're almost coming to the close of the session. But for now, I'm having the questions loading on my side. So yeah, let me ask. What tools are recommended for AI model deployment? Dockers and Kubernetes, or what tools?
Well, it depends a lot on like the infrastructure you're working with, the customer you're working with. So for some customers, a single Docker container might be enough, but for some others, you might need to include some more complex things together. So it really depends. In my experience, since our customers are not always open to the internet, because you might have some restrictions on the way you share your data. That's common in manufacturing companies. You might also have some restriction on the type of device you can place in a plant. in a production plant. So that's like we handle that case by case actually. So my only suggestion is to have a broad understanding of the general tools. So like things like you can see in the courses I shared. And then like with that general overview of the tools available, you can build your own like necessities. You can cope with your necessities that arise for that particular customer.
Okay, thank you for that. So on to the next question. While developing machine learning real-world projects for production, what are the things that are taken into consideration?
Well, there are a lot of things to be taken into consideration. For me, one of the most relevant ones has been to have a clear metric and be totally transparent with the customer about how the workflow of machine learning is. So how iterative this process is. Because one of the most difficult things to handle is like when the expectations from the customer exceed the technology, and that's very common given all the hype around AI. So one of the most important things for me is like to have that clear agreement on the metrics you could expect or the success criteria for a project. For me, that's the most relevant thing.
So how can one tackle data quality challenges like blurry images, applicables, other missing features, images, vision AI? How can we solve the class imbalancing?
Okay, so for working with images, is not actually a problem to have blurry images. That's kind of an advantage actually, or a technique we even use to have a more complex data set to train our models and a more like sufficient data set. So it's actually not a problem. For class imbalance, that's actually something I needed to handle in my last project. There are a few techniques, like for instance, you could oversample your training data in a way that you have the same number of examples per class. In our case was per defect type, because we were inspecting some devices and looking for some defects on those devices. You can also play with the loss function of your model. So like most people know about the cross-entropy loss in a classification model, but you could add things like weights to the cross-entropy loss so that it's more relevant to solve problems with the classes with less examples. So yeah, you can play with the loss function. There are also some loss functions that are already designed to tackle that class imbalance problem. Yeah, that are some of the things you could do.
Okay. In production, how do train test works, and what are the frequencies to train with new data, and how new data will be an input as training set?
Can you repeat again?
In production, how do train tests works? What are the frequencies to train new data, and how can new data be input as training sets, something like that?
Okay. Well, since like as I suggested before, you need to keep track of how the model is doing. and that shadowing of the model, that way of keeping track of the model, lets you realize when you need to train again. So one clear thing is when the data distribution changes because of some environmental conditions, then that's a clear point where you might need to retrain your models, and you might need to gather new training data for that. Testing your model, usually you might have a fixed test set or fixed validation set if you consider that the distribution of your data is not changing, but otherwise you might want to constantly have more data to test the model to keep track of its performance.
Okay. How can you deploy machine learning and AI model using Python? How can you deploy machine learning and AI model built using Python using Laravel framework?
Well, I have no idea. I've never used Laravel, so I cannot answer that question.
Okay, thank you. We'll probably have someone else to answer it later on. Yeah, so let me see if we have any more questions. How do we handle fast-seen categorical values as the testing data differ from the training? Okay.
How do we handle first-seen categorical values as the testing data differ from the training? Well, I'm not sure I understand the question actually. So I feel like whatever answer I give might be misleading because I honestly don't understand the question properly.
Okay, I'll perhaps ask for clarity from the person who asked. So thank you so much for taking the time to answer the questions from the audience. We really appreciate it. Yeah.
You're very welcome.
So thank you so much thank you so much, Mr. Sebastian, for taking us through your session. I believe we're getting to learn a lot, and also having our questions answered. We've been able to learn a lot from you, and we do greatly appreciate. And thank you so much for creating time, and all the way from Colombia. And thank you so much. And at this moment now, we would like to usher in our next moderator so that she can take us through the next speaker and what we will be tackling next. So from this side, thank you so much, Mr. Sebastian. We will also get to learn more from you. Thank you.
Thank you.
Hello, everyone. I hope you can hear me. Thank you very much, Ken, for this opportunity. So, greetings to you all. I hope you are keeping safe and staying at home. And I hope the webinar is coming along nicely as you had expected. I'm Daisy Okacha, the Microsoft student partner at the University of Nairobi. I'm part of the casting team today. I hope you've been able to engage so far and taken a few notes. Joining us virtually today is Mr. Brian Muhia. He is a former Smart.ai fellow interested in low resource languages. He is the first machine learning engineer hire at UT Technologies. This is a Kenyan-based startup. He continues to be actively involved in shaping, building, and empowering AI hubs and data science communities in Kenya. Brian, if you can hear me, do say hi.
Hi, everyone. It's a pleasure
Okay,
to be here. It's a pleasure to participate in this.
Sorry for that. Thank you very much. We'll delve right into the questions. May as well proceed to share your screen, Brian.
Okay. Are we still screen sharing, or is it better to just walk through the talk?
You can share your screen.
Okay. Thank you. Just a second. Okay.
Are you good to go?
Should be good now.
You're
All
good
right.
to go?
Yes. I think
Oh, okay, thank you. Cool.
So, yeah, we can proceed with the questions.
Okay. So this comes as a concern amongst most machine learning engineers who are starting out. So I'm concerned about the direction my project is going. When is the right time to talk about ethics? Is it too late? What are your thoughts, therefore, on interpretable machine learning, that's explainable AI, and machine learning biasness? Are there any techniques and approaches you would recommend practitioners to implement as they strive to build adoptable solutions?
Cool. These are like really important questions for a really important problem. So
Yeah.
there's a whole set of knowledge and a whole set of ideas coming from the field of ethics and software development. Software and ethics are very, very difficult to work on after the fact. Like, you have to think about these problems before the project even starts. And as Chris earlier said, this is a part of a product development pipeline. It's not, machine learning does not sit in a silo where, like, it doesn't follow the same rules as other fields of software development. So at any given point in time, there are opportunities and options for people to actually step back and look at what the real customers are, who the real customers are, how they are supposed to be helped and affected by the work that they're doing. So first and foremost, a machine learning engineer, even a machine learning researcher, is first and foremost a software developer, and any principle that is supposed to help with that is actually applicable. And anything that helps with product development is useful here. So from conducting diverse interviews for customers, from to supporting people when the data you have is not labeled properly. There's so many different techniques for enabling things like that. We'll see here, like, the second point here is that we need to put people's real needs for equity and safety at the forefront of the product that you're building. So whatever it is you're building, whether it's a social site or it's a dating app or it's a food delivery platform or it's a platform for supporting doctors, a platform for collecting health data from patients, all of these things, they depend on, should put people at the forefront, right? And it's especially if it's supposed to be an application to look at, for which people actually are trying to log in directly as individuals. The situation is even more fraught when you're building a product that customers, as like the individual on the street, will not see that it's supposed to support one company from another company. And there's usually a lot of very hidden data. There's usually a lot of very hidden contracts and contacts that as a person on the street, you will never get access to. And even those systems, they should be following the same kinds of ethical ideas. Basically, look at product development, look at, like, what the pipeline is, see how many, and see, like, how to look at the solution without thinking about the technology as at the forefront, because the technology is not the point. It's the people and how to help them. These questions are the things that should be at the forefront all the time. So I'm going to share a resource of several articles and talks given by people who have been actively thinking about machine ethics and ethics in AI. One of them is by Tawana Petty, who I've quoted here, saying technology doesn't think of humans after it's been innovated. An example of this situation is when I guess a service like a model to predict the recidivism rates in prisons. So I don't know of any examples locally, but we can definitely look at like cities that have a lot of black and brown people in them that also have a lot of advanced technology and can be called smart cities. An example is Detroit. In Detroit, it's very difficult to get equitable justice because most of the models have been developed not from that, not focusing on that community's needs and what its resources actually are. So it doesn't actually take into account what the social relationships between people there are, and even if it did well, what's happening is the policy behind the deployment does not support any of the data. So we get issues with uh, people not being supported by the communities that they're in, and it basically puts on blockers for so many different things. One of them is like among communities that label data, and it's one of those things where like if you catch it at the beginning of the project, you can actually solve the problem in a much better way. If your data needs labels, like for example, a data set that almost everyone in the world has been using in image recognition, ImageNet, it turned out that it wasn't really diversely labeled at all. And that affected some of the models that were constructed. Lots of people had a lot of commentary on it, and it's not. And the problems don't end with the people figuring it out and making commentary about it. The problem ends when the data is actually either redistributed in a better way or relabeled or something like that. Because as long as those labels are being used for anything, whatever judgments those algorithms, ImageNet-based algorithms will make, um, if they're actually focused on people, then it will actually affect things, especially if people actually just directly using the weights and not, I guess, doing proper transfer learning, which I'll talk about a bit later. Um, for an interpretability, there are several very important and interesting techniques that have come out along the years. And interpretability, the way I see it is like you want to see what your data is teaching your model, which parts of your data are important for which part for the decisions your model is making. One of the most, I guess, modern, reliable, and adaptable techniques nowadays is called GradCam, or class activation maps, which are understood as a way to overlay the weights of your model over the image that is being studied at that point in time, whatever just passed to the model. What this does is that it basically highlights which parts of your model which parts of your data are useful for prediction. I will share these slides will contain all sorts of interesting links to all of the things that I'm talking about, and you'll be able to get a chance to dive in later. So you basically overlay the weights on the image, and then you can get predictions directly from there. You can also use class activation maps if you have an image classifier. So this technique is for image classifiers, but I think it can also be applied for text because we have convolutional-based text NLP systems now, things like BAT and GPT-2. Any attention-based model can be used for these settings. You can use them to turn a classifier into a segmentation model, or a simple segmentation model before you actually go to human annotation. So it's a way to take advantage of the labels in your model, such that you can have an actual visual representation of the prediction, and then from there you can actually train a new model that can learn how to be a segmentation model. Another example is, basically, that's why I include also as a third point, taking advantage of segmentation models and segmentation approaches for images and text. These segmentation approaches are labeled situations, which means it actually involves a community of people, and you also need to take advantage of the diversity of the labelers and improve it so that people can actually make correct predictions and verifiable predictions. There's a whole lot of techniques for making crowdsourcing tools more equitable and useful, where when labeling data, or when you're labeling data using a public tool, such as a tool I created called CocoHub, which lets you label and annotate text by providing translations. You basically take all the predictions or all the labels that are provided by people, and then you open them up for voting by people, and you can figure out whatever voting method is most appropriate. So a voting method can be something like it can be just direct one person, one vote voting, where everyone who votes for a particular label as the most accurate label just gets that prediction. You can also include voting like quadratic voting, which basically takes the sum of the squares of the number of votes for particular label. Basically takes into account the community of labelers, and basically prevents one person from taking over the votes for from other people. So the more you vote for something, the less your vote has influence of other people's votes. And there are also preferential voting and things like that. There's so many different ways to include the voice of other people. And that's what all of this is about, actually, like actually finding out how to include the public's perception and actually educating them on what the data is actually doing. Another technique is feature importances for random forests. This is random forests random forests are extremely useful because in terms of in the interpretability sense, because you're providing it with column data, and all those bits of information can actually segmented and separated from each other. So if you and feature importance is actually usually quite important when you're actually training the model. So if you do better on that, and if you learn how to actually use that for your tabular models, then it will actually help your model become more explainable. It actually take advantage of the structure of the data. So yeah, here I've taken into account both structured and unstructured data. You can segment text, you can segment images, you can learn class activation maps for your images, and you can also use those to create segmentation models which are even better. Then how to make models more adaptable. This is actually quite similar to the final question, which is which strategies we can implement to ensure that we consistently output solid predictions over time and detecting distributional shift. It's very similar, so I'll include some of those things here as well. We can take advantage of unsupervised learning and transfer learning for your unlabeled data, and then collect as much of it as you can. Nowadays, there are techniques which let you there was a time when transfer learning from ImageNet models was considered to be the best possible starting point, which is still true. But what happens is now, in order to get out of the data of the ImageNet point of view, you don't actually have to train a classifier at first. What people do, what people have seen trying out now, and there's a lot of there's actually very new challenges coming out on Kaggle right now for taking advantage of unlabeled data. So here's something that's happening in production in a lot of communities, in a lot of companies and projects. Because of the way apps are designed, people don't always have the ability to relabel the data as a customer. So as an example, if you've used Google Lens, whenever you take a picture and then Google is gives you the text that was extracted from the picture, it will ask you whether the label was accurate, and sometimes it might even ask you to say what was there, like whether which text was there in order to relabel it. So and then use active learning to retrain your model based on that relabeling effort. That's the simplest possible way to start. But if you don't, if your product has been launched without that feature, how do you take what will happen is that you get a lot of data and the predictions from the model, or whether it was a classifier or whatever. But what you really need is a way to actually use that data, regardless of the model, and improve the model without relabeling, without actually spending more effort on labeling. And that's what unsupervised learning is for. The modern state of the art in text classification is all unsupervised now. We have universal language model fine-tuning for text classification. We have BART. We have so many other, like GPT-2, for example. What happens there? You basically train a model to figure out to predict the next word in a sentence. In some cases, like ULM fit, and you can also train a model to predict the middle word or something, like delete a word from a sentence and then predict that word by passing through the other words in a sentence. That's called close deletion. So those two tasks are important for text, because what happens is the embedding matrices that are attached to each token are large enough to take into account each word's relationship with every other word in the whole data set. And if you take out one word, or if you're trying to predict the next word in a sequence, what it will do is the model will learn quite a bit more about the language data. And if you give it an unsupervised data set, like say Wikipedia, you can imagine training a model on Wikipedia itself, which is about 6 gigabytes of plain text. That contains a lot of very important linguistic content and embedded knowledge about how the English language actually works. And then you can fine tune it for any other task you like. If you have a question, it's actually a good idea to raise your hand, and then at some point in time, I'll just pause and see if I can answer it. I've gone a bit deep, and if you want to get some clarity on something I'm saying, please don't hesitate to raise your hand and then ask. Then for images, we have SimClear, which is simple. It's described as a simple method for contrastive learning. What this does is that it takes a model. It can be an untrained model. It can be an ImageNet-based model like ResNet 50 or something like that. And the task you train the model on is not to classify your images, but to fix a damaged version of that image. So imagine when Sebastian earlier talked about data augmentation, and what that data augmentation does for you is that it creates a lot more diverse images from the data set you already have, effectively giving you up to 4 times or even 5 times more data than you already have by slightly modifying it. So the way you take advantage of data augmentation in this case is that you augment your images, sure, but instead of passing them through a classifier, you pass them through a model that can predict either the modified part to recreate it. And earlier I talked about, in this, I've gone back to the previous slide, I talked about the last point of taking advantage of segmentation approaches. This is an example of that, taking advantage of segmentation. So in semantic segmentation, we have models like UNets, and what UNets do is that they let you, or even, actually UNets are probably a good example, but they're actually quite meaning. They basically help you predict the pixels in a particular image. Then you can train a unit to predict the pixels of the image directly that are missing in an image that you've slightly destroyed or slightly modified a little bit. And if you do that with enough kinds of augmentations and enough kinds of variations of the data that you have, you get a model that has learned how to fix that type of data. And then you can use that and then you can fine tune that in the normal way of classifying or fine tuning a classifier like an image-based model. In active learning, there's a lot of very interesting research being done right now. It's still quite open, and what people are trying to do is figure out how to best take advantage of people's relabeling efforts and how to also predict it all ahead of time. It takes into account what people are actually participating in the system with. And it also offers a direct interface for apps to actually pass the predictions from other people and actually use them to improve the model. So for deployment, we have so many different things. I don't think I have time to collate everything. But some of the most interesting and useful tools are the same tools you'd normally use as a student or as a participant, because what happens is if you don't, since all of the tools are open source, you can just take advantage of each. DevOps is like its own process. Like there's so many different kinds of tools and techniques that are taking even one of them and going deep on it isn't that beneficial. But we can go through Ansible, Docker, and Kubernetes, which Chris talked about. And then for models, especially for heavy models, taking advantage of async IO tools like Starlet and Quart in Python. There's and even more important, I haven't added it here, but it's taking into account all of the available data that is, all the available computation that is available out there. So almost everyone has a smartphone now. You can retrain models on the phone. and you can actually do it quite efficiently. So if you deploy a model as a federated learning project, for example, and that's its own journey for enhancing privacy and safety for AI. You can actually use tools like OpenMind, which support the training of models in a federated and almost decentralized way. Yeah, and then finally, we have situations where projects are failing in production. Why does it happen? Well, it starts from the beginning, really. It's the beginning of the project. How much of a product focus is there within your team, and how much of a customer focus is there within your team. That's what really causes everything that is going on. The construction of the team that is creating the system or the product, they will make decisions about the product ahead of time, even long before anyone trains a model or anything like that. Those design decisions are actually a much bigger problem than the model, because they can replace a model to make it more accurate. But if the model is supporting an unethical process, or like a failing system, for example, then the whole cause is lost. So it's all at any given time, it's always a product design problem, but technology is not always the solution, right? It can be just a matter of figuring out which part of the community the product is supposed to be supporting. And as long as you go back to that, the drawing board at any given moment, you're not guaranteed success, but you're guaranteed at least a fair process for determining the accuracy or the performance of the system that you're building. This is all about reorganizing and understanding the metrics that you have in your system and understanding why they're useful. Machine learning engineering is part of software engineering and product development. It's firmly within that realm. And if a software system that you or someone has built is unethical, whether or not it had ML in it is not the issue. It's like the community that created it. What are their thought process? What are their visions? Why do they want to actually participate and perform and actually do any of that stuff? Another production issue is class imbalance, and it can be taken to be an accuracy problem, but it's actually quite a bit more than that. If you're not using a public data set, and if you actually collected all of the data yourself, which situations surrounding the product design are making data to be unavailable for certain particular things. An example here could be anomaly detection for fraud detection, for example. That's a fundamental part of the problem, because necessarily fraudulent accounts and fraudulent purchases are anomalies, and they don't have to be as frequent. If they were more frequent than the normal situation, then the product would be pretty much doomed by the time that those decisions being made, which is important. Which is why it's important to really think about the data imbalance problem for things like that very much ahead of time, because all of those decisions, since they affect such a small part of the data, an incorrect decision that is globally that is used for all parts of the data globally is going to make the product decision, also the product itself, much less effective. Think about all those things ahead of time is the most important part of all of this. I think we can work on. I think there should be some time for questions, so that we can enhance the engaging part of this talk.
Yes, thank you for taking us through the questions. Over to you, Tabby. Do we have questions on Slido for Brian?
Yeah, thank you so much, Brian. So I'll just give a few questions from the audience. So Brian, what advice would you give to someone who is completely new in the field and hopes to remain relevant for a long time?
That's an interesting and nice question. So if you're new to the field, you have the biggest advantage you have is that this field is changing all the time. So whatever you find, whatever tools you find available, you, your mastery of them will transfer the degree to which you're persistent. So persistent is the first thing. Things are difficult, like a lot of the interesting things start with just making sure that you understand what the fundamentals really are. But you don't actually have to start with, let's say, like an advanced graduate level textbook on machine learning in order to actually get some stuff done. Because the main issue in ML engineering is actually writing code. Right? Like writing code is the thing that will separate you from any other engineer. Like if you're not actually building stuff and testing your own hypothesis about things, then you won't really make much progress. So always keeping a beginner's mind, always keeping an eye on the world itself, because remember, machine learning isn't just about software. It's not about making predictions or models. It is, but it's not. That's not really the main focus. The main focus is to do something out there in the world, right? Making actually affecting people in some way, or making a prediction in some way, like about the world. So the question is, which part of the world are you interested in, right? If you want to learn better, choose the data sets or choose the experiences or projects that will most motivate you, right, as an individual. This isn't something that a lecturer can give you, or anyone. Like, this is something that you give to yourself because you are interested in something in the world. If you're interested in medicine, cool. There are lots of medical imaging data sets. Focus on that. And as far as tools are concerned, my go-to as far as practical deep learning is concerned is Fast AI. Like, I've taken that course 4 times. And I'm quite interested in actually co-organizing a study group for people so that we can actually go through the course together. So if you want to do something like that, you can reach out to me on Twitter. My handle is on the chat on Zoom. It will also be shared on, I think it's already been shared on YouTube as well, because I can't see it. So if you want to participate, this is like, all of this stuff is open in the community, so you can just join and participate. The resources, a lot of the resources are free, like Colab, the Google Collaboratory. You can use that. You can use a lot of very interesting, useful platforms like Doc AI, which lets you actually provide data to doctors and stuff like that. You can also use some tools that let you actually access Jupyter notebooks in the cloud. So you can access a GPU in case you don't have one, which is like the biggest benefit of all. Like, if you have access to that, and you can basically just practice and learn with as many interesting projects as possible. Another one is just don't if you can choose interesting data sets, but don't let the size of the data sets limit you from actually learning. You can always create a smaller version of the data set you have access to. If the data set you have is, I don't know, 10 gigabytes, make a 1 gigabyte version of that and then train your models and learn using the smaller version of it. Because whatever you get, if it works on the smaller version, it will work on the main system. Yeah, so that's some of the things I can say about like what kinds of things to keep in mind as a beginner.
All right. So is it true that I should have a master's to get a job as an ML engineer? I am self-trained, and this scares me a lot.
No, it's not true. Not necessarily true. Remember, what's happening is you can have access to educational content, right? And practice and actually build things and as long as you're on that path, as long as you're actually focused on the product, then that's what determines what's success. The amount of focus that you have that you can come up with is really the limiting factor. Like, how much time you want to dedicate to the situation, either to study or to solving a particular problem. Yeah, so it's important for social reasons, like having like to my mind, that's what the real purpose is. It's important but not for enhancing your focus. If you if you can get the resources to actually spend the time and energy to actually study, it doesn't have to be full time. In a master's degree, the advantage is that you're actually doing it full time, but obviously now that's not really the case because schools are closed. So like, what are people actually going to do? So you really have to find the time and the energy for yourself, focus on the problems that you care about, on the data sets that you care about, and keep your eyes open as much as possible to make sure that you're always seeing more opportunities and more ways to study and enhance the data that you set.
Okay, awesome. That's nice. Thank you so much for answering the questions. We'll keep you engaged. And thank you so much to the audience for keeping the questions coming on. I think, Brian, someone is suggesting that you should maybe perhaps open your Twitter DM. I'm not sure if it's open or closed. Maybe you should open it so people can reach out to you concerning the study group, because there's some who are really interested to know what the study group is about and some would like to join. So yeah, I don't know if that's possible, or what do you have to say about that?
Sure. You can just reach out to me, and then we'll talk on Twitter. As long as we can organize a time to set it up, then you can just get started and actually just start participating and actually working on the problems. So and this is like so before when I was talking about taking advantage of unsupervised learning, like this is actually a focus for me right now, for both for images and for text. So like my personal projects are almost all in the unsupervised learning space right now. So that's that. If anyone wants to reach out and talk about this, then just reach out to me and then we'll talk about it. Whatever field you're working in, as long as it includes either images or text, it's something that we can just dive into and then go through a fast AI study group for the course, and then that'll give everyone a level footing to start with.
Awesome. Thank you so much for that. Thank you so much for also being able to answer us. To the audience, if you feel like you've asked your question and I've not really addressed it, please don't worry. Keep the questions coming. We'll still find time to address all the questions that are available. For now, we are just limiting them because of time. So yeah, over to the next bit of the session.
Great. So thank you so much, Mr. Brian Muhia, for creating your time to getting to speak to us, getting to share with us the insights, getting to answer burning questions. And I believe, as we've been informed, if you still have more questions coming for Mr. Brian, keep them coming, share them on Slido, keep your suggestions coming. And I believe at the end of the session, we'll also be able to also get to hear from him as he gets to share with us his final input. So keep the question coming, keep your suggestions, and let's keep the conversation going. At this point, I'm hoping that we're getting to learn a lot, we're getting to gain in-depth insights, and also having our questions answered. And at this point, I will welcome the next moderator to take us through the next session. So Griffin, very much welcome to take us through to the next session. Griffin, if you can hear me. Okay, great. Seems maybe he's not in a position to get to take us through that session. We will have our next speaker, and our next speaker is Mies Hao. She is a machine learning engineer at Airbnb. She's been actively involved. Great. I hope you can all hear me well.
You have to listen and call again. When you press one, hold on for them to respond.
Sorry for the technical hitch. Griffin, if you can hear me, I believe you can take us through the next session.
Hello, Kennedy. Are you able to hear me now?
Yes. You can go on.
Okay. So greetings everyone once again, and I'm Griffin. I'll be taking you through the next round of Q&A webinar part of this session. And next on deck is Mia Zhao, and we'd be damned if we never had a female presenter for this live Q&A webinar session. So we're glad to have with us Mia Zhao. She is a senior machine learning engineer at Airbnb at San Francisco, and she was previously a chief data scientist at PlayStation, and also a senior machine learning engineer at Bloomberg. She holds an MSc in information management from the University of Washington, and she has published several publications and knowledge on discovery and data mining. She specializes in building AI solutions that seek to improve travel experience for community. And again, just like the sessions we're having today, she is actively involved in shaping, building and empowering AI communities in San Francisco through the deeplearning.ai, Pi and AI meetups, like the one we're having today. And one thing about Mia is that her favorite food is durian. Durian is tropical fruit distinguished by its large size and spiky hard outer shells. She particularly loves the scent of durian very much. And so, Mia, if you can hear me, say jumbo.
Jumbo.
Okay. So at this stage, I'll go right away to the questions. So, Mia, in your own words, what does it mean to you deploying a machine learning model? What factors does a machine learning engineer need to consider when determining how to deploy models so as to move from production in the lab so as to move from practice in the lab and to production in the industry?
Sure, yeah. So, Grimmy, thank you for the introduction and the question. So I think I have the right to take over to share the slides with me.
Yeah, quite okay, quite sure.
Yeah, can I take over and sharing my screen? Can you all see my screen now?
Yeah, we can see the screen.
Cool. So thank you for the question you just asked about deploying a machine learning model to production. This is something we have been done like it's our daily job. So the thing is we have to understand what the business needs are and help ship the models to production actively. So there's a lot of things and factors on my mind related to this question. So I just list the ones I think that is that often occurs through the practitioner when shipping a model to production. The question often I ask is, first, where do we ingest model in business workflow? This is, I think this question maybe needs to be asked even before the model gets development. For example, if we have a trust model to say if a listing is a fake or not, we won't say, okay, when this model will be triggered in the business flow. Is it going to be triggered at the time user to enter a listing, or at the time user to edit a listing, or at the time user is complete a listing? So there are different stages we can trigger this model that will definitely influence what the features model can take. So this is something I would consider as a very first question you need to think about. Where do we place the model before we go production? And then second area I'm sharing here is about the feature requirement for models. There is, like from my past experience, there are some trade-off between a feature latency versus the model performance. So there are some live features that is a very important feature to streaming in, such as, okay, user just purchase this item, or user just get something, and then if we have a recommendation model, we hope that feature come in as fast as possible, so we can cater users' newer preference into the model considerations. However, there is a very expensive cost involving in having a streaming feature versus a normal feature, because all the streaming jobs takes quite a bit of time to set up, and the cost for that is also high due to a lot of times we have to make the batch job to be consistent with the offline features versus the online features. There's a lot of validation needs to be done. So often, from my personal experience, I always test. So like, for example, if I use the feature that is done it offline versus the feature that is just happened 5 minutes ago or 10 minutes ago or for 1 hour ago, what model performance lift would be that feature do? So from this perspective, I often get a better sense, okay, about how latency my feature going to be requirement to get into the model on production. The third thing is often the API requirement is something we need to do. My experience, there are most of the times the ML model are served as a backend services versus a client, a model hosted on the client side. There are more and more models hosted just on the device side. For example, like the Apple is trying to now sending the people PII information. So they do all the machine learning model on the client side, so they don't collect the user specific PII data. But from my understanding, a lot of models they are hosting on the service side. So that means there is a client needs to call that server, give some users information, and then the model returns back the prediction. In that way, how we define API requirement is also very important here, because that will for us to consider, okay, are we getting features from the upstreaming API? Give me that feature, or I have to fetch that feature from a downstreaming databases or key value stores to get that feature. So this is something that we often consider at the first stage when we ship the model to production, see how many feature engineering work we have to prepare for that model to be online. The fourth element here is how to handle exceptional and fallback cases on production. This is something, it's a very interesting perspective about those cases. So a lot of times, in reality, when we do the model offline, we often see an offline performance with a data we were prepared. But online, there could be a lot of exceptions having. For example, there are exceptions like we don't have enough latencies. So the latency is too high. And then the client have, if the latency goes that high, like greater than 200 milliseconds, we will fall back to a default logic instead of machine learning model. For example, if we are missing some data, then the model can now make the decisions, then we will fall back to that logic. So my experience tell me is we have also needs to be very careful to design those fallback logics, because sometimes that will influence experiments results a lot in that fallback cases, because how you decide your fallback cases will also influence the model performance in the experiments. One example I had in the past is we do find a lot of fieldings on the latency side, and then all its fallback to a default logic, which does which has the model like a recommendation system sort as chronologically versus as user caters. So when we through the experiment, we actually find the performance is worse. And then we look at the logs, we find that feedback. So this is something I would put in my mind to carefully design those cases when the model or the data is not working. The fifth point here is about model evaluations. Of course, this is the experiment design about the model evaluations. Often we have this saying, often there are a couple of different metrics here. A business metrics that the business want to improve, which the experiment should improve. And the second one is the model metrics, which is we train offline. A common example here is if it's a ranking model, usually the offline metrics might be the mean average position or NDCG, which is normalized accumulative gain. But online, when the business metrics will often becomes like, okay, how many lift are we getting from a booking? What is the click rate lift, or what is the booking rate lifts, or what is active users per month? That's even a near-term metrics to consider. So when we design experiments and the model, we need to consider hopefully the model metrics to be more consistent with business metrics. So that means your model gain offline can probably have a positive online influence as well. So this is something we need to heavily spend time in when we shift the model to production. The sixth point is logging. I find that this is fairly useful when consider how we log the data into production. Even sometimes we log the ML predictions in the middle. That will help a lot in terms of debug. I think a famous problem we all know is ML models. For ML models, it's even harder to debug sometimes because not like the software engineering, you can expect something to return with a given value. But sometimes, for example, recommendations, you don't know if that is good or not. You have no idea about that. Your prediction is good, but often through your own logging, you can help you decide that. Especially when you have an ensemble model. Say you have a model, you have several different models, you're taking a majority vote or average of those models. And then if you log the individual model predictions and also logging some other things you might be like using this may be important for your debugging, I would definitely recommend a best practice to do that, because that's solving a lot of monitoring and issues downstreaming after your model gets deployed. The seventh point is the feature consistency. This is often also a model related problems through offline and online features. A lot of times we have the model experienced offline has a significant gain. When we put it online on production, we see actually the model perform very differently. This is more like the online and offline features are not consistent through the handling. It could be due to a data processing issue or data handling issue, or there's a logging missing issue, and then this could be all also the data consistent issues. One way we consider for solving that is mostly thinking about how we even do the shadow testings before we go prod. So what the shadow testing does is we actually shadow some of the traffic, and then the same production traffic to the dev environment for that model, but the model output is not directly serving the client, it's logging somewhere. And then we look at the performance and trying to see if that is performed very consistently with offline testings. Sometimes you will discover if there's a discrepancy, most likely it will be a feature issue. The 8th point I list here is a on-call schedule and alerting mechanism. This is something also on mine, because ever since like as a machine learning engineer, we deploy model on production, we should be responsible for the on-call schedules like a software engineer. So this is expected, but how to set up a alert system and mechanism is very important as well. For example, it's like software engineer, if the traffic, the memory hits some limit or the latency hits some limit, you get alert. For ML models, your alert might be very different. So it can be your data distributions are output towards a very skewed distribution, you trigger alert. So all those alert mechanism is something we need to consider if we are on call. The next point is continuous model monitoring. When we deploy a model to production, we are hoping it to do it long-term iterations, and then to be able to monitor the model performance is also very important. As I said, it's not like a software. When model breaks, it's very hard to detect it because the model just suddenly produce meaningful numbers for the predictions too, but it's just not expected or effective. So have an online modeling monitoring dashboard to keep you track what is the prediction and then what might be the real performance is very helpful. The last point is of course, the model upgrade schedule, or we can say the model update schedule. If your model is online learning, that's fine. But if the model is not, you probably want to retrain your model like every month or every quarter. Then there is something you want to experiment is if you use your current model to predict next week's data versus 3 months of data later, what's your model accuracy decrease? So what I often do is if model accuracy decrease a lot through week to week, I will consider the retraining process to be a little bit frequent. But if the model performance isn't changing too much by predicting this month versus next month's data, I would consider put a monthly or quarterly retraining schedules.
Great. Thank you so much, Mia, for the insights. You have really elaborated so well and clearly, and I hope the live audience have been taking notes. Now, to the second question. What computer science and software engineering practices should an ML practitioner implement when handling ML operations?
Yeah, so I think this is a question about software versus ML. So my opinion is it is very different from software and machine learning perspective, because we know the best practice for software engineering is you write unit test before your actual code. That's kind of best practice because you know how your code gonna be designed look like. But this is very different in ML model because you often want to experiment a lot of times till you feel like the model is ready for production or when it's gained enough offline performance. Then you will think, okay, how are we gonna shift that model to production? At that time, when you write a unit code test or code test, your model, you probably already written your majority of your code. So the question here is, should we follow the software practice? I think it's still beneficial if you want to ship your code on production. So because it still can provide you some like a simple dumb error. We actually just had a error like in our production today is something like data we never seen before. Then we find there's a bug in the feature normalization function, which is when something is all the features are not that we never see it in offline, but online it could be happen when it's divided by 0. It's just throw out the exceptions, and then it crashes. I think this often these cases we can say if we had a unit test already written for that cases, it would be super helpful. So actually, in my team, so we are starting to implement some of the unit test code for the model, especially for the models we consider continue evolving each times. So when different people are touching the same model, adding different features, often it's easy to break something that the person is not aware of. And so in this cases, I think adding a test cases often is very helpful, and then for these cases, so that it ensure your model is valid and in a lot of simple test cases. Although you can say I'm not expecting a clear output, like normal function versus my model, but you can still expect something you should not have when you handle like extreme features or extreme data. So like this is from my personal experience.
Great, Mia. And we have in the world of the field of data science, there are constantly dynamic technologies that keep evolving day in and day out. So we have these frameworks, tools, and architectures that are introduced to us on a daily basis. What specific tools could you recommend that our attendees today go ahead and explore? Tools that will enable them scale their data science operations and ship models to deployment, but yet again make maintenance of these models quite easier.
Sure, yeah. So
Mia, did you?
Yeah, I think can you hear me? Can you hear me?
Yeah, I can hear you.
Yes.
Okay. Yeah, I think my let me share my screen again, because I think my internet might be a little bit delayed. So to be sure for that question, because I would like to share something that I actually did in my current work. So about the tool we use, I think in my previous company, when I work with in PlayStations, I experienced a very different architecture than the machine learning architecture I have in Airbnb. My personal experience is the tools I'm working with Airbnb is actually much better. In my previous work, I would say when I deploy a model to production, it took me probably 2 to 3 months to have a model on production ready. But with Airbnb, all the ML infras we had, so I would say I can deploy a model probably 2 weeks on production. So this is definitely save a lot of times with a good infra. The framework we're using is called Big Head. It's an open source, actually. There's open source framework. So the idea is the data scientist, the machine learning engineer, they only take care of the feature generation and the model training and transforming code. So the pipeline is automatically generated. The model UI is automatically generated. The service API, which is hosted on Kubernetes, is automatically generated. And then so as the data logs, the logs are automatically generated in terms of the latency, memory, and those common metrics. Of course, for customized logins, you probably to add in your code. So I think this is a very powerful machine learning platform we're using right now that actually really speeds up the like turnaround of shipping machine learning models on production. And this is the first framework we're using. The second one, I would say, is the big head is more about modeling side. Of course, feature side is also very important to do. Zipline is another product we're using. It's not open source yet, but in the line, it's just it was using Spark streaming, and then we switched to Flink. Essentially, it's a streaming services, so it allows you to streaming the logs to transform to a features with like within past we say a second, so that will give you some very very real-time features for the model to consume. So this is another pipeline I was using. And then for the other features, such as the offline features, which is the Airflow, that we often use, which is a job scheduler. You can write DAX. This is open source as well. You can write DAX across different features, and then have your job scheduled to run across different logs. So you can have a schedule process log A, and then goes to another pipeline log B, and then you combine those, have some feature engineering code down, finally lands to another table, say table C. So for those like normal feature handling work, Airflow can do it well. So those are the tools I have been using. Like for it, I think it's really depends on the needs. One thing I would emphasize on the big hat side is, I see the questions audience probably asked previously about like a Docker image, if we're using, yes. On the big hat side, for the underlying models, because it's using Docker image, it doesn't limit to what machine learning libraries you're using. Those are very flexible. So as long as you have attached your own Docker into your model, that will ship everything for you. One challenge is often we using a Spark pipeline to handle offline transformation. Say if my model is not real-time service, my model is a function that I want to transform a list of data to predict something and save in another table. So often these times when data scale is large, Spark is placed. Within the Spark, I think they just announced a new feature that you can set up your like own environment, similar like the Dockers. You have your own libraries to write on the Spark nodes, and then send out to write this. Before that, the Spark had to share all the jobs in one environment. Like all the models have to share the same environment of the Spark. This is pain because different models will have different dependencies. But with the new, I think, launch with the AWS launch with the Spark EMR, they just announced you can separate your environment over there. So this helps a lot of jobs and models. But we spend more times on the Spark side than we on the Docker side. So on the Docker side, we have much less issues. Yeah, I think that's like all the experience or tools I'm using right now.
Great, Mia. Thanks for sharing some of the tools that you do use at your workplace, and I hope we'll be able to experiment and implement models using the same. Now, to the third question, Mia, why is it that machine learning teams have hard time setting goals and expectations, and what do you recommend to managing expectations and handling people and the technologies that are involved?
Sure. Thank you for the question. So this is hard to set expectations because often, well, like in our business metrics, often you have an OKR, but it's hard for a machine learning team to say, I have an OKR say to improve the model performance by X% in this quarter, because this is something it's often out of control. So one thing is there's a gap between a model metrics versus business metrics. Even you do it really hard to improve your model metrics. Even you work really hard to improve our model metrics, your business metrics might not improve according to our expectations. That's why setting an OKR with absolute performance is very hard. Also, the experience can be, the experiments can be impacted by other elements. So in order for other partners to understand these limitations, so what we do often is we do a lot of information session sharing. We also do ML universities and tutorials for other people to better understand what the machine learning does. So they can have more realistic expectations about what the model can do and cannot do. So in my previous job, I think that we had a machine learning university inside the company, which is we have the software engineer, we have the PMs. They each session is for different target of the users. What usually is they sign up, we give them some talks, and then we give some assignment they do. Each of the session each of the quarter involves 3 months, which is after that, they will know machine learning much more than us. I think the most effective one we did is with the PMs, the product manager. After the session is done, after they know much about the machine learning, oftentimes they will plan better for us, even for the product features. I think this is a very useful thing to share. And then we don't want them to think about machine learning as a black box or mystery. Oftentimes we try to use a simplest language to have some intuition-based explanations on them, on why this is working, why the model performance is often based on data, not just on the model itself, why the data is very important in this way, and then how will model, like what's the realistic expectations for the model to achieve. So I would think slowly having them, influencing them through different knowledge sessions or tutorials, information sharings would definitely help them to do that, because this is something I think machine learning. I think from deep learning, there's a code AI is electricity. If it's a very common utility that everyone uses, it's good for everyone to know what it is. So by better understanding that, it just helps working together to achieve a better business goal.
Great, Mia. Somebody is just curious to know, what do you mean by OKR on your slide here?
Oh, sorry. So OKR, yeah. So it's a business term. I forgot to explain here. I think it's a key achievement. So this is something like each of the team set up for each of the quarter. Usually you say, okay, for the quarter, my goal is to improve a coverage for this language by 5%. Say if I'm an infrastructure team, my goal is say I'm gonna saving cost by 10% this quarter. So this is my goal. So this is kind of a key business goal to achieve when you do the planning before the business ends. At the evaluation period, you will pull out your OKR, say, okay, at the beginning of this quarter, I set up these goals. How many of them do I achieve it?
All right, great. Thanks for that. I hope our audience are have gotten help from that explanation. Now, we'll be picking two questions that have been coming in for you from our moderator on the other side, the session webinar. Tabitha, if you can be able to splash up your screen and share 2 or 3 questions for Mia.
Okay. All right. All right. All right. So the questions I'll quickly ask Mia. How to get how do you get an entry level as an AI or ML engineer? Like I have a big unemployment gap and I want to gain work experience.
I think for this question, it's a little bit hard at this time because a lot of companies are freezing hire. But from my experiences, like a lot of companies, they want people with some experience, especially in a machine learning world or data science world. One way I would say when we achieve that is you can go to some of the nonprofit organizations and do at first you can targeting them. So I feel like a lot of nonprofit organizations they often have a lot of data, but they don't know how to handle it. One example I had it before was I was doing the volunteer for garbage collection on beach. I find out that at the end of the volunteer, they ask people to hand the sheets to them, say what type of the garbage they actually threw up away. So the data they are collecting, but they're not using it. So I volunteer actually working for them to do some data mining of their collected data and show some results. I think those are very good project experiences versus I'm not saying the cable computations isn't good enough, but I think those are more real world cases that you can show your impact to the organizations. So through those experience, I would say you should be able to get a better real world projects, which help you to get an entry level ML job.
Thank you so much for the response. What's the biggest challenge you faced during your past experiences in machine learning projects with respect to customer satisfaction, and what advice would you give?
So the question is biggest challenge you face. I think customer satisfaction, yes, of course, this is very important thing to consider. A machine learning challenge, I think for a lot of machine learning models, a lot of times when we have some very exciting offline experiment, we ship down production, we see the experience has gain, and then we put on production. And then often, a lot of times we forget to monitoring or involving them over time. I think this is a very big challenges. And then it just sometimes the model just breaks without any alerting, and then this will definitely hurt customer satisfactions or user experiences. I think user experience is the key. Usually we treat at this. That's what key to our problem, and the user have bad experience about the model predictions. This is the challenge we want to solve, and hope to have the machine learning model to be maintained and under monitoring for a long term way.
Thank you so much for that. So those are the only questions we'll be answering for now because of time. I'll quickly would like to take us to, let me see. to our poll, just to the audience. We asked you questions like, what do you expect from this live Pi and AI webinar? And most of you will really love to get insights from the webinar speakers, which I'm hoping that you are getting by now at this particular point during the whole event. And also for those who are seeking to find your way in machine learning and AI, I'm hoping that you are starting to find your way. For those who wanted to have their burning questions answered, I want to believe that we are trying our best to answer the questions, as well as networking. We'll get to do this at around the end of the whole session. So yeah, thank you so much for your participation. Let's continue engaging and sharing the proceedings of the event actively on social media, on Twitter, LinkedIn, the hashtags Pi and AIUN, tag at deeplearning.ai, at MSPUN, at DSUN, at Andrew NG. And yeah, let's keep learning. Thank you.
Great. Thank you so much, Tabi, from your end. Maybe just one question for Mia before she leaves. There is somebody from the audience, Tanvi, who wants to know which open source tool is better for feature generation.
You mean feature engineering?
Yes, yes, exactly.
Like for my personal experiences, I used H2O. I think that this is open source as well. I think it does pretty automatic ways about feature engineering side things. It's automatically detected fairly well. The experiment we done is we publish a homework to ML University, ask like 10 students to do, and then we just use the H2O package to do it automatically. And then we find out the top 1 students only beats the H2O package a little bit. So I would say this is a very smart package to do feature engineering versus we actually publish the homework to the students. I think this is worth looking. And then I know Google AutoML has some good reputations as well. We had tried, but we never compared that result versus human work.
All right, great. I hope that was helpful to Tanvi and all of us. So Mia, thank you so much for spending the time and having to beat geographical time zones to be here with us today. And too much love from us, the organizers and the attendees here today who have been able to benefit from your insights. So Mia, if you stick around for a few minutes, no problem. But if you're leaving, then thank you so much. We greatly appreciate. So over, yes, Mia?
Yeah, sure, it's my pleasure. Thank you.
Great. So over to the next moderator.
Greetings, everyone. My name is Lydia Gathoni, and I'll be handling the next moderator. I want to welcome Billy Otieno to the panel. Mr. Billy Otieno is a data scientist at Oracle Africa, Kenya. He is an advanced analytics and machine learning practitioner with over 3 years of experience in solving business-related problems to financial risk management. He has previously served as a data science consultant at Oracle, Kenya. Billy is actively involved in the Python open source community, STEM education, and leadership trainings. He is also passionate about open data, social innovation, digital strategy, and data ethics. He is also actively involved in shaping, building, and empowering AI hubs and data science communities in Kenya. Fun fact about Billy, he is a pencil artist and he really enjoys dancing. Billy Otieno, can you hear me?
Yes, I can hear you, Lydia. Can you hear me?
Yes, I can hear you.
Okay. So, Lydia, thank you for the introductions. My name is Billy. I work as a data science consultant within Oracle. So, majorly my day in the life basically involves working with clients just to take analytics products from the foundational level to basically the highest level of analytics, which is machine learning, and even pushing more in terms of workloads production. And I'm really glad to be here at this point, and I really appreciate the fact that we have come together as a community, and bearing the fact that we're in sort of a difficult situation globally when it comes to coronavirus, and I really hope that everyone is taking care back at home. And yeah, I think that's basically be my introduction. Yeah.
Thank you so much, Billy. We'll just dive right into our question for today.
Yes.
And the question is in regard to privacy. We all know that as ML engineers, it is scary to put our models out here. So what do you think we need to know about privacy? And are there any tools specifically made for privacy and machine learning in production?
Okay. So when basically when I think of privacy and this is basically has been a sort of a huge concern, and looking at in the previous years and the news that we basically had from the previous year. Now, first of all, just to bring in privacy into perspective, if we look at previous years and specifically in 2018, and not even 2018, if you look at 2019, when we had a lot of information on privacy releases by Edward Snowden, which happened around 2013. And then in 2018, there was a lot of things related to Facebook and basically Cambridge Analytica that resulted to basically doing some sort of an organization basically were able to basically look at users' data and basically to do some sort of a political targeting and a couple of things, and then which led to, in effect, the constitution of the GDPR laws from the European Union coming into effect across Europe and even affecting other markets consequently. Now, when I think of privacy and how I think of it as a machine learning and data practitioner, I think yes. In essence, it's scary because particularly of the penalties that are associated with all these privacy concerns and data releases and hacks around different sections of the world and attacks on different companies, and it's the fact that the penalties that are involved in it and sort of the policies that protect privacy around the world, which means that we sort of need to create some sort of mechanisms to ensure privacy within our machine learning production system, or even in effect any software engineering platforms that we're sort of building. Now, if we looking at all this, in effect, the happenings that have been happening in the industry, they basically only highlight the importance of privacy and emphasize on the focus that we as data community needs to give around privacy, and in particularly when we are building our systems. Now, if you look at the industry, now privacy usually presents itself in a very unique challenge, and particularly in regards to machine learning and data management. Now, but what we've been able to see and far and wide is that research is sort of merging with what's happening in the enterprise. And there's a lot of development regarding how to maintain privacy within systems, and in particularly more focus on privacy preserving machine learning systems. So if you basically look at privacy and how privacy was being tackled in a traditional sort of perspective, and it also happens a lot. I've seen this in the East African and the Kenyan market by and large, is that how organizations basically do handle privacy is more so majorly by using cryptographic algorithms. So basically, which means and they are doing a lot of encryption in data, and also some of the time basically involves the using removal of basically private information from data. So if private information is in training data, so in effect they just pull it out. But now the question I'll basically ask is this something that's really privacy oriented? Is it in effect how the best way to handle privacy? Now, looking at this on a broader perspective, I've seen research around that have proven some of the traditional mechanisms of handling privacy, which broadly concern the removal of private information. And it has been regarded as somewhat a very naive approach and a very risky, taking into consideration now in effect the aspect of big data and machine learning requires a lot of consumption of lots of data, basically to do some sort of learning and improve systems and drive optimization. Now, if you look at some of the, in technical terms, some of the bits and mechanisms that were used, like K anonymity, L diversity, and T closeness within the big data ecosystem traditionally were focused on hiding some elements of personal information. For example, putting stars in, for example, credit data, which we always see a couple of times, encrypting credit information. But how does this really improve privacy? Now, if we look back in research that was done by a group of researchers from the University of Texas. So in 2006, Netflix had announced a contract to improve its rating, mobile rating protection, and publish their dataset of around 10 million anonymous movie ratings, which was had around 500,000 customers. So basically, what these two researchers did was they came up with a way to de-anonymize some of the data, and how they did it was by comparing anonymous movie ranking with information from IMDb. So these researchers doing this, they were able to somehow figure out some sensitive information about the sort of the users and the data points, political affiliations, and other personal details. Now, in light of such as this research and so many additional proofs that have showcased in effect the sort of the need of privacy, and the fact that so many adversarial attackers are looking towards breaching in effect privacy, so they can get data that can drive some particular mission, either political or even some private sort of mission that affects the community at large. So if you look at how organizations, tech communities are sort of behaving, and they have in effect been affected by privacy by and large. Now, companies like Google and Apple are now coming up with various ways and concepts that we can learn from and even use to enhance privacy within our ML systems, either locally or even globally. So some of the two approaches that have come across widely and in regards to privacy preserving machine learning and data analytics, the two approaches are federated learning and differential privacy. So by looking at what we mean by federated learning is when you have a sort of a distributed machine learning infrastructure, such that training is only done on the client side. And then all the private aspects regarding a particular client is only left on the client device. And what you only take is the model updates to the sort of centralized environment. So you no longer keep data regarding the client. So instead of sending the data to the client into a centralized location, which creates opportunities for compromise. So in a federated learning, basically what happens is you send the model to the devices participating in the entire federation network. And then the model is retrained within the local setup. It could be an IoT machine, it could be a mobile device, and then the data never leaves sort of the device. So it's only the model updates that move to the centralized location, and then sort of the updates are sort of taking place. And then the next approach is usually is differential privacy, which in simple terms, it's a mathematical formula that basically involves adding of statistical noise to some components of rows of data, just to create some level of plausible deniability, so that in effect you cannot attribute a particular data point to someone. It gives them that confidence of denying that this is not me, and this does not describe me in any sort of way. So if I look at and also in addition to that, I've also heard of homophobic encryption, which comes from the cryptographic world. Now this basically involves allowing the recipient of the data to encrypt sort of either the data and the result of the computation now. so that without sort of knowing the input. I haven't looked much into that, but the most things I've seen in play is federated learning and differential privacy. Now, if I looked on the tooling, and as mentioned in the question that was just put out, now when I look at the tooling in the industry, I know TensorFlow is quite rich, owing to the fact that Google has faced a lot of issues related to privacy, and I'll ask Brian to chip in regarding homophobic encryption. Brian is an expert in sort of privacy, and Brian, I'll involve you just a couple of just yes, could you just give support in that update?
Okay, cool. Hi. So basically, you can think of all of these privacy tools as considering the strengths of privacy and then the strengths of machine learning. What homomorphic encryption is you basically take you can encrypt data, and then you can also encrypt the functions themselves in such a way that you can compute on encrypted data and then get encrypted output, and then use that output as part of another, part of the normal output of a model. That way, you don't sacrifice the model if you don't want to release the model to the public, or you don't want to make it available if it should be private. And then you can also make you can also make it more secure for the users, because they don't have to share their data to anyone in order to get the performance they need out of it. So this class of technologies is on the bleeding edge of what people are actually trying to accomplish right now. And homomorphic encryption is like it's like at the most R&D stage, because for some kinds of computation, homomorphic encryption isn't really the best kind of thing. So like for an example is you can only compute 7 adds or multiplies in sequence on encrypted data before the computation becomes too expensive, and then you have to reset it again, which means that inference on using homomorphic encryption would be much slower, significantly slower than it is on normal data. So what people have opted to do instead is focus on something called multi-party computation, or secure multi-party computation. If you want to learn more about this, you can check out a project called OpenMind, OpenMind. So this is a privacy-preserving machine learning library. They have a lot of tutorials and examples showing exactly how all of this stuff works. Yeah, and the examples on how to learn more about it on because it's implemented in both PyTorch and TensorFlow, so you can actually learn how to use it for pretty much any kind of data you have access to.
Yeah, thank you, Brian. So in terms of the tools, apart from what Brian has mentioned, Google also has TensorFlow privacy, an open source library that majorly focuses on the principles of differential privacy. And then we have the TensorFlow federated, and also in effect the aspect of federated learning and architecting systems within decentralized sort of machine learning sort of platform. And then recently, I think Google also open source a C++ library that they're using internally for differential privacy. You can probably look at that and see on how basically what lessons can we learn, and how can we tweak it even to a lot of local examples and applying privacy on a broader scale. Yeah.
Okay, Billy, thank you so much for those insights. Thank you for sharing with us. To the next question. When it comes to implementing online inference for ML development, there are a few challenges that ML practitioners face when serving models in an online inference scheme, including near real-time features generation, online model validation through A/B tests, rolling out different model versions, and monitoring deployments. Can you kindly share with us how to handle each and considerations for when creating an online implementation is and isn't required?
Okay, so first of all, I'd like to sort of lay the context for online inference. And basically, the meaning that we the meaning that we refer to as online inference is it's like real-time sort of serving of models in sort of a synchronous manner. This means low latency in terms of predictions. And if I just bring such a scenario in lively in some sort of an application, I'll think in terms of let's say we are coming up with an ML platform for an e-commerce platform that serves real-time product recommendation, such like what Amazon basically does. So in such a system, based on user interactions with the product, looking at various factors like web page logs and online transactions, for example, moving on the shopping carts. So this scenario puts us in a position to sort of look at when somebody does something, looks up at a particular product, recommendations and serves are sort of updated and served sort of in an immediate manner. So this is one of a typical case where you apply to deploy a modern sort of an online inference scheme. So, and when it comes to an online inference, the latency for like responses is in sort of milliseconds to the least. So you're also you're targeting a very low response time, which means your infrastructure needs to be updated and strong. And there's a lot of focus on in terms of maintenance of your entire infrastructure in regards to making sure it's real time and gives feedback in sort of in an immediate manner. Now, if we look at a real concept within our own normal usage within for inference, online inference. Now, a real example would be, for example, if you look at your Uber app. Now, it usually feeds you conceptually with an estimated time of arrival, or even an estimated sort of charge immediately when you sort of set your destination and then your location. And this is usually based on factors such as time, traffic conditions, and so these are sort of changing factors within the environment. Now, Uber serves this in sort of an online mode, just to make sure predictions are served as quickly as possible. Now, you as a user, in effect, you don't feel the sort of the sort of delays. So essentially, looking at the requirements for online inference, now this is the focus point. You don't want the user to feel like you sort of our user clicked as product recommendation, but then you serve the recommendation 30 minutes later. In effect, it doesn't really materialize as a proper online inference sort of mode. So for an online inference, basically, for basically a machine learning model to provide a prediction for a given data point in a very timely fashion. So a data point must always include all the input features that the model expects. So now, what basically happens within the framework of feature generation? What happens is, in most cases, these features, whenever a customer interacts with the website, these features are usually stored in sort of in a real-time fashion, in a sort of a NoSQL data store, just to make sure you factor in the latency concerns. And then features normally, if you look at how even Google applies its online inference, they break down features into two kinds of sets. So there are those static features that and remember this is real time. It's coming on a very speedy fashion. So you store some static features that are normally common to a particular given prediction entity. For example, age, customer demographic, and then there are all those other dynamic real-time features. For example, the events, web page clicks, and stuff. So now these other dynamic features are stored separately in sort of in a different store, and then aggregated in real time, just to make sure the feature generation and feature calculation is sort of computed and aggregated in a sort of quicker manner. So in most cases, you'll find for online prediction and basically online inference, most organizations, what they do, they usually cache the prediction or even pre-compute the predictions, and then they serve the predictions that are already pre-computed earlier. So you, for example, take a window, a given window, because now data is coming in a streaming function. So you decide a batch window for a given set of inputs training, and then you take that data the predictions that result from that data, you cache them, and then you just serve them as immediately, so that the user doesn't feel that, in essence, any sort of delays when it comes to that. So when it comes to A/B testing within the framework of online inference, and particularly regarding evaluation, is quite difficult in essence, because it's also a lot of times dependent on the infrastructure setup for quicker online inference. Now, I haven't been put in stage. I would like basically to understand how evaluation happens within the online mode. But how I know it is like there's some aspects of batch evaluation in regards to A/B testing within an online mode. Because if you are looking at sort of the frequency and the throughput required for online predictions, so what they do is you do A/B testing somehow offline, and then cache the predictions for the optimal model, and then you can be able to serve that model. And then if you look at majorly monitoring in regards to looking at online inference, we look at very efficient sort of open tools being used to capture the logs within various systems. I've seen tools in use like Kibana, LogDNA, Grafana within the enterprise realm. And now the main essence is to how do you capture the logs in a sort of high frequency sort of way. Now, what are some of the considerations that you look at when you look at online inference on a broader perspective? Now, I've just talked about federated learning when it came to basically privacy. Now, let's say you're working in a very high privacy setup. In essence, the data that you're dealing with is too sensitive. Now, you might decide that now what you'll do is just you go work in the client. You basically push your models to the client side, and then basically training happens on remotely on the client side, and then it sends sort of data and model updates to the online central server just to update the sort of the global model. Now, in such a scenario, you can use basically online inference when you're working on things like federated learning. So this is important because you're looking at preserving privacy and ensuring security within your system. Now, secondly, when you're looking at if your training data is sort of very high and it's not easy to transfer even to an offline process, it's very easy to transfer to an online process. So issues like network traffic barrier. Now, places like Africa with low like network accessibility, now you might decide that your device will sort of work in an offline mode, do train offline, and then push the results sort of online, and whenever the device is connected to a network. And then thirdly, you can look at, for example, in most cases, you find that you're working with very huge training data sets. And you have, let's say, infrastructure limitations. So your data sets somehow can't fit into memory of a single machine, let's say, at a given time. So you might decide that let me use take data in a streaming fashion just to minimize on the storage capacity that's required. And then you use that quickly working on basically online inference, taking sets of data within different timing functions. And then looking at centralized training and distribution, I think I've mentioned regarding that. So online inference on a broader perspective, sometimes it might help you when in cases when, for example, if you think of when I train a centralized model and I push the model to the devices, if you think of it as a sort of an expensive affair, because it is, yes, you might decide that you might the best methodology to use is some sort of a online inference, just to make sure that you optimize on some of the cost in regards to that. So on basically my closing note when you're looking at online inference, I think the best advice I'll give is if by any chance you can solve machine learning model by looking at running periodic jobs, and this is in reference to batches. For example, on a weekly, on a bi-monthly or on a monthly level, and you're starting and you're in the beginning of starting off, unless you have a very optimum and clear infrastructure, I would suggest you don't put yourself in the pains and the requirements for evaluation and monitoring within an online inference design. I would easily suggest that you do batch. Now, reason being is sometimes it's the complexities around an online inference requires sort of complex teams within enterprises. And I know locally our level of maturity in regards to machine learning is still getting up, because you see, you'll find a single person doing machine learning within an organization. But in other markets, it's sort of developed when a machine learning engineer exclusively focus on something like deployment. Somebody focuses on evaluation. But in the local ecosystem, what happens is that a single person handles all the roles. So in such a case scenario, it's complex to manage. You can imagine managing as a single person, and then also sometimes within online inference, you have to take some strong consideration in terms of versioning models within that ecosystem.
Okay, thank you so much, Billy. Just a question. What role does GDPR play in ML privacy, according to you?
So if you look at GDPR and the major focus on the global data protection rights, there are there are core critical components that GDPR sort of looks at. And the main focus for the global data protection rights is to protect basically consumers' data. Now let's look at and some of the aspects that are mentioned regarding GDPR. Now, when you look at how organizations are sort of subjected to deal and work with clients' data, the first point of effect that is sort of underlined is on the protection of personal data. Now, looking at number one, security of processing, and which is majorly regarded and connected to infrastructure. So there's some sort of way that GDPR requires us to sort of anonymize and encrypt personal data. Now, if it's in some sort of way users or clients' data is sort of breached, then there's a lot of penalties associated with allowing that, and not basically thinking on that on a prior way when sort of designing a sort of an infrastructure. Now, you are sort of mandated to somehow, when a client sort of requests for their data, you're sort of mandated to provide it, and sort of highlight how you're using this data, and what kind of processing are you doing on this data, and sort of the implications on processing this data to basically in effect to the privacy of the user. Now, looking at how solid GDPR is into protecting our individual privacy rights, it has created that policy framework that all these organizations within Europe and also in other countries are sort of subjected to when processing data for people in Europe. And also, I've seen also laws within the East African market also sort of tuning themselves towards in essence, the umbrella of the GDPR, just to protect privacy. Now, for me, the role of my focus point as a data practitioner and a machine learning engineer is to understand GDPR, because when you fall into the sort of the risk that are associated with not looking at security of processing private data and expose users' information just out of ignorance, I mean, I think it puts you into the risk of falling out in terms of maybe paying a lot of damages, and also to in essence to your credibility as a data practitioner, and also the credibility of organization by and large.
Okay, that is well explained and exhaustive. I will now welcome Tabitha, who will take us through the questions from our audience on our Slido platform. Tabitha.
Okay. So for the questions, there's a question that was of concern. Thinking about the recent case of Cambridge Analytica, is it wrong if I build a system that collects user data illegally but highly benefits the community?
So okay, so so collects user data illegally and highly benefits the community. So if I think of these two concepts that you mentioned, so the fact that you're collecting user data illegally, it's already a breach. However, even though you're sort of even though your principles is towards maybe benefiting the users, the fact it's like you're doing it deliberately, collecting user data just illegally. Now the question is, I'll ask this person is why should you collect this data illegally? Yet there are other options of collecting it in a legal manner and yet still providing value in regards to creating a system out of it. So I think when we think on privacy, there's no like it's never there's never a gray area when it comes to privacy. And even if you're doing something, collecting data illegally just to make sure you help some particular communities, I think at some point it removes the facts that essentially you're helping people, but in essence you need to look at how your collection mechanisms in terms of enforcing privacy across the board in terms of your whole pipeline of deployment, whether you're collecting data and whether you're serving customers with a particular need. I think there's no gray area when it comes to privacy, and I will just insist on that. When we look at privacy, let's look at it on a solid ground. And the solid ground is that privacy has to be enforced across the board on an entire sort of pipeline.
Okay. Another interesting question here. How can you create a justifiable or explainable AI if machine learning privacy hides the person's attributes? What role does GDPR play in this? I think you've answered this.
Yeah.
So we see if there's another question. There's a question about machine learning and Python. If you are in a position to answer it.
Yeah.
About how to deploy machine learning and an AI model built using Python, using Laravel framework.
So okay, for in regards to that, so you build your machine learning model in Python, yes. Mm-hmm. Now, the advantage of machine learning infrastructure, it enables you to make some choices that are sort of code independent, code base independent, which means now you have the capacity of building sort of a microservice framework for your machine learning model. That's basically within Python. And then I'm presuming Laravel is sort of a front-end user-facing sort of platform that interacts with this model. Now, the disadvantage in regards to using the different sort of in code base is that there'll be a lot of throughput, but now you can use infrastructure to overlay that because when your infrastructure is sort of strong and you have microservices that serve this model, and probably you're looking into in fact load balancing, and then these models and predictions are also sort of pushed to this Laravel front-end system in a very consistent manner, then you can be able to hack that. So it's possible, but you have to think in a very in a microservices kind of mode, and then look to use Dockers and Kubernetes just to make sure infrastructure is sort of solid in terms of deployment and exposing the model to the Laravel sort of client side.
Okay. We know that the AI is the new electricity, but in a developing country, they are becoming a slave of other technology. So then how can artificial intelligence solve this and other problems?
So in terms of, just repeat the question, I just need to grasp.
So the question reads, we know AI is the new electricity, but in a developing country, they are becoming a slave of other technology. Then how can AI solve this and other problems? I don't know if it's quite clear.
I think I'm struggling to understand these questions that developing countries are becoming slaves of other technologies. I don't know if what basically is being implied here is the fact that yes, we're exposing sort of our data to the pre-existing developed technologies, but not we don't have a way of building that within the African ecosystem. Now, I'm not actually for that. I think the concept here is that as African ML engineers, when we really need to think about how can we improve our systems, either within government and even within our different social enterprises, and even within different NGOs, just to make sure that they improve their capacity towards driving social impact, and majorly through machine learning. And I think if we can come up as a community and work on things that focus on improving on a broader perspective the impact ecosystem within Africa, just to make sure services are provided in an efficient manner, basically within government. If you look at private sector, that works efficiently, basically in the intersection of AI. But I'm not sort of avoiding the fact that we have a lot of challenges within Africa, and the first thing is in regards to our data is sort of I will describe as I think our data is some sort of in offline mode in some sort of a way, and so we really need to build our data system that consolidates data fast, because most of our data is actually offline. You can if you work in various, if you work only in business, you'll find that you'll get a lot of data regarding particular transactions within businesses. But if you come outside as a citizen data scientist, then you find guys asking, hey, how can I get this sort of data? Because now communities have not built an ecosystem of sharing data and making sure data is available for ML communities just to create products and projects of impact as well. So I think that's an advice to the community.
Thank you for that. Are you able to accommodate another question? Because I have several for you.
Yes, it's okay. Yes.
Yeah, so machine learning concepts tend to be overwhelming. Which is the best way to gauge and ensure that I'm studying the right concepts? I am self-trained.
Okay, so when you being self-trained, I'm also self-trained actually. I wasn't taught in essence machine learning in school, and now looking at in effect, and I'm looking at this personally, and I can connect to the person who has asked that question, that sometimes it's overwhelming. There's the multiple level of concepts within machine learning, but I think the best approach will be to work in some sort of on a sometimes we are pressured to achieve all the concept in a singular sort of sitting, or just a single understanding. You want to learn everything at once. So I think it's more about organizing your studies and how you organize your learning process, because in essence machine learning it's sort of wide. Now you look at things. If you look in the industry, there's things to do with data engineering, and then there's things to do basically with data science, now the building of insights, designing of models. And then we look at machine learning engineering, which is in essence combined some aspect of software engineering just to push these productions, the models into production. Now these are three sort of different fields. Now how do you grow out of that? And which strength do you want to build? So you look at it in terms of skills. So building skill set. So for example, you build skill set regarding data engineering, creation of data platforms, querying data, doing dissection of data, doing transformation and stuff. And then you move towards building insights, working on a couple of technologies and products, slowly by slowly. Then you move towards looking into production. So when you work in a sort of in a managed sort of way, and looking at focusing on skill building instead of probably and skill building has to be augmented with on a practical approach. So a practical approach, which means doing projects within this specific sort of modes and specific areas. Now, one way I've been able to learn a lot when it comes to machine learning and stuff is through the deeplearning.ai community. Now, I've done a lot of learnings within Coursera, just to looking at deep learning AI. And these courses are sort of pre-formatted in a way that they give you base knowledge, and then they grow your knowledge now to the top level of thinking that happens within Google, within Facebook. So you are able to have a futuristic perspective on how machine learning happens within production. So I suggest you sign up for a course that takes you from the beginner stage to the end, and has some very good feedback in regards to what do you learn next and what's the next stage from here. And then it offers more of a progressive approach. I think the thing is, when you go online, you find a lot of resources scattered everywhere. And then when you start on one resource, another resource impresses you, then you get confused, you move to the other one. So I think you need a good learning approach. And the beauty of the online learning that has provided, it enables you now to learn at your pace and at your speed as well. Yeah.
Thank you so much for your response. I think one last thing I will ask is the audience would like to know your Twitter handle so that they could probably reach out to you concerning some issues, if that's okay with you.
Yeah, so my Twitter is @ so I'll just push it here.
Okay.
On the chat.
Okay.
Yeah, I'll just done it.
Okay. Thank you so much.
Thank you.
Great. Thank you so much, Mr. Billy, and also to Chabi. Hoping that we're getting to learn as much and having our burning questions answered by our speakers. And I'm also hoping that we're getting to cultivate the product development mindset and getting to move away from just building machine learning models to getting to building innovative data products. And at this point, I'll get to introduce our last speaker for this session. And our last speaker for this session will be T. Scott Clendaniel. He did relay his apologies. He would not be able to join us for this session remotely due to a couple of factors and reasons that just happened. And but still, he was able to do a recording for us of his whole presentation. I'll quickly get to introduce him, and then we'll get to hear, even if he's not here with us, to get to answer our questions that we will have after his presentation. But still, we'll be able to get to hear his message and what he had in terms of insights and what he had to share to us based on the feedback questions that we did share with him. So yes, Mr. Clendaniel has amassed vast experience over 34 years in business analytics and artificial intelligence. He is the chief data scientist supporting the strategic artificial intelligence lab and data science strategy at Legg Mason, that is based in Baltimore, Maryland. He specializes in making AI accessible to everyone, designing and developing new machine learning departments for mid-level to large size organizations. He's an active advocate and AI consultant to Harvard University. He's had previous clients working in organizations that he's worked on, some of them being Bose, Allen, Hamilton, amongst others. So at this moment, we're going to hear his video presentation that he had for us. So let's get to hear what he had for us.
Hello and welcome. This is Scott Clendaniel offering a presentation on deploying artificial intelligence, machine learning in production. First thing I want to point out before I begin the actual presentation is a disclaimer. All the opinions that I'm going to be presenting to you are my own. They do not necessarily reflect the views of any of my past employers, clients, organizations, people, pets, or anything else I can think of. So if it's something that you disagree with, it's probably something I came up with on my own. Thank you. Continuing that same disclaimer, These are some of the clients I've worked for in the past, just to give you an idea of my background. IBM, Mercedes-Benz, Booz Allen Hamilton, Bristol Myers Squibb, Audi, Wells Fargo. Let's start off on why we're having this conversation in the first part, which is to discuss a little bit about the promise of AI. Why is artificial intelligence talked about so much? Let's review some quick facts. The market growth for AI will accelerate at a cumulative average growth rate of over 33% over the next few years. The incremental growth between 2018 and 2023 is supposed to be $75.5 billion. The year-over-year growth estimate for 2019 is estimated at over 29%. Unfortunately, you'll also see that the market is fragmented, with several players occupying most of the market share. 61% of the growth is originating from North America, although you'll also see that China is coming on strong. One of the key drivers for this market will be increased employee productivity, the theory being augmented intelligence, which is the topic of artificial intelligence that's used to assist people in getting their jobs done. Now, AMC Laboratories has a bit of a different take, but the same basic idea. A growth rate of $118.6 billion forecast for global AI market by the year 2025. So as you can see, that is a ridiculously high amount of growth, and one of the reasons why there's so much attention to the field. Let's also take a look about what Accenture, the international consulting company, has to say. They're arguing that artificial intelligence is actually the future of growth itself. The conclusion essentially is, if you're going to have any key driver of growth that you're going to monitor and capitalize on, it's definitely going to be artificial intelligence. Now, if you combine this with some research that was done about 5-6 years ago by a company called Nucleus Research, they found that the return on investment for typical analytics project is between 900 and 1,200%. So in other words, if you put $1 into artificial intelligence, specifically analytics for business, you're expected to get $9 to $12 back for every dollar you put in. I don't know of any other technology that can provide anywhere near this amount of growth, which is one of the reasons why there's a lot of focus on it. Now, this is a scary one, but it gives you the idea of how much the general public has become interested in this. If you look at this ad from an investment site, which I'm not going to necessarily suggest that you go to or use a whole lot, artificial intelligence share to invest for huge profit. When you start getting into the public mainstream to the degree that they want to try and sell you stocks or investment based on artificial intelligence, you know that the general concept of this is caught on. So how are people supposed to get there? What is the method by which artificial intelligence is supposed to provide all of this profitability? How does it work in an ideal world, at least? If you'll start with the upper right-hand corner, where you'll see this graphic with the 5 chevrons, you go from data to analysis. The analysis gains insights. The insights provide recommendations on which actions to take, and then the actions drive the value. Now, this is really important. A lot of folks in the data science community are really into the first 3. Excuse me. They want to be able to identify the data. They want to be able to do their models. They want to be able to do all types of analysis. They want to run their Python scripts. They want to build all these pipelines. All those things are great. But unless the insights make it to the action channel, those insights are relatively useless. If I can't take advantage of what I've learned, then what I've learned doesn't have a whole lot of value. This is also going to come back to play in a conversation we're going to have shortly. Now, here is a diagram that was actually created by the software company SAS. They broke out the following wheel in terms of the process that you're supposed to follow. First, you identify or formulate the problem. Next, you work on the data preparation. These are all the steps for data cleaning, all the things that most data scientists don't really particularly like to work on. Data exploration, so this would be EDH, or EDA, exploratory data analysis. Then you're going to transform and select the final variables that are going to go into your model. You're going to build the model. You're going to validate the model. You're going to deploy the model. And you're going to evaluate and monitor the results. What most of the press likes to focus on is here, building the model. They're very big on telling you which algorithm you want to use. They're very big on saying that deep learning is the solution to everything. Hint, it isn't. But that is where a lot of their focus is. So what I want to do is warn you that actually where the wheels tend to come off in this process comes from these three on the left, and specifically the deployment and the monitoring of the results. Now we're going to talk to what I refer to as the yawning gulf, also known as the yawing gulf. All right, so we just talked about all this growth in artificial intelligence and all the benefit that it's supposed to be able to provide us. But what we're going to see now is there are a lot of headlines out there that indicate that this isn't actually happening. Take a look at the big data ROI failure rate from an organization called Barn Raisers. Where is the big data ROI? Now notice the date on this. This is going all the way back to 2015, when the hype cycle was really starting to kick into overdrive. They were saying early on that all the push towards big data itself wasn't really providing a lot of return on the investment that folks had put in. Then let's look at the AI failure rate itself, in terms of not just the big data, but AI as a whole seems to be falling down on the job. Notice the statistic. Why do 87% of data science projects never make it into production? That's a ridiculous failure rate. It's huge. Why is it so high? I don't know of a whole lot of industries or technologies that can survive on just a 13% success rate. That's horrible. But that's not the only headline that seems to be indicating this. Research from Gartner indicates 85% of AI projects will not deliver for chief intelligence officers. Okay, so what is going on here? Gartner holds one of the biggest conferences in the country on data and analytics every spring, and they're finding that 85% of the projects from the clients that they research aren't making it. It doesn't seem to be getting any better. As of March the 2nd of 2020, you've got another article, this time from an organization called Designing for Analytics. 85% of data science projects fail. What is going on? Clearly, there is a ridiculous gap between the promise of AI that we talked about and the actual reality of what's going to happen. So let's go back to the diagrams that we just talked about a moment ago. Notice on the top right, you see these two boxes for action and value. This is where things seem to be falling apart, which is also these two boxes in the circle diagram we just mentioned, deploying the model and evaluating the model, and the text version down here in the lower left-hand corner. Yet this isn't what people want to spend their time talking about. There isn't a whole lot of press out there on deployment, which is why I'm really glad that there are conferences that are being able to address this topic. So what I'd like to offer is just some top 10 artificial intelligence deployment tips to help you navigate through the process and actually make it to the first group of slides about the growth and the promise of profitability from AI, as opposed to having the issues with 87% or 85% of the projects never making it. Tip number 1, I want to take you back in time to the year 1989. The most popular business book ever written was by a gentleman named Dr. Stephen Covey. It was The 7 Habits of Highly Effective People. If you're as old as I am, you will remember a time where you could not escape The 7 Habits of Highly Effective People. It was the first nonfiction book ever to sell over 1 million copies and is still the best-selling business book in history. Just an amazing accomplishment. He laid out 7 different habits that would allow you to be a very effective manager. And the second habit was actually pretty simple, but it applies very much to implementation here. And it was called begin with the end in mind. What he meant by that is when you're designing a project, especially an artificial intelligence project, it becomes so easy to get wrapped up in all the excitement, to become entranced with what algorithm am I going to use? How am I going to present the results? What technology am I going to implement? You know, the infamous R versus Python debate, or maybe now we have to put it in Scala. All those things are important. But when you're making those decisions, it's really easy to get caught up in the minutiae and the trivia. Instead, what you want to do is to think, for every decision that I make, how is this going to implement the actual end result? Or another way of thinking of this is to use the phrase, project the future into the present. If I was doing this right now, in this very moment, what would be the best option for me? If I actually had the model in my hands today, it was all finished, all the fun stuff is done, what would I be doing with it? Would my data look the same? Would my implementation path look the same? What technology would I be scoring the records with? What type of KPIs am I going to have on the performance? Start with those things first when you're laying out the plan for how you're going to get your project in place. Tip number 2. This is a really easy one to skip, and it's not a good idea. Identify your stakeholders' needs and goals. I have a hidden secret for you. Artificial intelligence and models are about people, not about technologies. Again, everyone wants to talk about the algorithm, but take a look at all the stakeholders you have to be considering when you're developing a plan for implementation. You've got regulators. By the way, folks, are you aware that if you're in the financial services industry, any type of a neural network is likely to get you in huge trouble with the United States regulators, at least? Most of the techniques are very hard to implement and meet with scrutiny. Basically, what they want you to be using is some version of linear or logistic regression or a scorecard, maybe a decision tree. Most of the popular functions that people are always talking about, such as random forests, neural networks, deep learning, you can't get them into place. Environmental partners, maybe not so much. However, there is a big push now with companies arguing against large tech companies building ridiculously large models because they require ridiculously large data centers. And ridiculously large data centers use a ridiculous amount of power and add to the carbon footprint. Bet you didn't see that one coming. Community groups, especially when we're talking about the topics of fairness and bias in models. What steps have you taken to be able to make sure that you don't have bias in your models? Think that through before you build your model. Don't try and slam it in at the last minute. Local authorities. Who needs to be notified about your project? What other things that you have to do? Is this going to cause local folks to lose jobs if you're going to outsource this to a different country to be able to implement, etc., etc., etc. I could go through each one of these and go through the same type of process. But the trick is when you're laying out your plan, you need to identify what your stakeholders want before you start building the models. Especially when we talk about customers and employees, think internal clients. How is the person who requested this model going to measure your success or failure? How is that going to be done? How are they going to implement it? What do they want? It's fantastic to you if you get an increase in the ROC of your project of 0.2%. If your client needs to have something in place by next Thursday, they may not care so much about that. Time may be their critical element. You need to know these things before you sit down and start building the model. Tip number 3. Identify model and project constraints. You'll notice that tip number 2 is finding out who your stakeholders were and what their concerns were. But how does this limit your project? I took this slide out of a project management site, projectmanager.com. The 10 constraints of project management. Is it sustainable? What about your organization? What method are you going to be using? Who are your customers going to be? How much time do you have? What's the cost going to be, and what is the potential cost savings or increase in revenue on the other end if the model works correctly? Scope. They're going to want to make sure that you're not boiling the ocean to be able to get this out. Quality. What are going to be their measurements of quality, and how are you going to have the model compare on that? Do you have reporting to be able to show it to them that that's true? Risk. What happens if your model goes down in the middle of production? Do you have a backup? What happens if the model actually scores backwards? No, I'm not kidding. That has actually happened in projects I have seen with clients implementing. The model scores upside down, so if they're trying to find customers, they actually end up predicting non-customers and end up driving an organizational project into the ground on a financial basis. Resources. What if you've got a company that is only using internal resources and refuses to use cloud-based sources, but you want to use AWS for building your model? You have to figure that out on the front end. Tip number 4, phase gate approvals. Now, the diagram here is helpful if you ignore this top level of labels that you have here. Phase gate actually came to me when I was working on project management, product development for a financial services organization. And the basic concept is this. For each stage in your model, you're going to want to build a gate. And the gate essentially says, do we have sufficient performance to go to the next stage or not? You must pass all the criteria for the first gate before you get to go to stage 1. To get to stage 2, you've got to pass by the criteria in gate 2. Gate 3 is required for stage 3, gate 4, stage 4, such and so forth, all the way to the end. What you want to do is to make sure that you have all of those gates in place and identified what are the criteria that allow you to get from step 1 to step 2. Let me give you a quick example. Let's say that you're going to predict the results of a particular stock in the stock market on a given day. What data are you allowed to use, and will the data be in-house? I worked for a very large financial services organization that was trying to predict the stock price. Let's call it stock A. And the idea is that on Monday, they would predict what the stock result was going to be for stock A on Tuesday. Fair enough. So I worked with them and I looked through the data that they were planning on using. Well, one of the elements was, what is the overall performance of the S&P 500 for predicting that stock price? Unfortunately, they were using the overall stock market performance for Tuesday to predict Tuesday's stock price. Well, the problem is they wanted to make this prediction on a Monday. So on Monday, you don't know what the stock price is going to be or what the overall S&P 500 is going to be on Tuesday. So you can't use that model using that data element. You're going to have data leakage. So you have to go ahead and make sure that you've accounted for that on the front end. And in this particular case, if you had a gate that indicated whether you could use that data or not, you'd say, no, that's not going to work. We've got a data leakage issue. You wouldn't allow the project to continue forward through all these other stages and waste a lot of time and resources because it wouldn't get through the initial stage that said, let's make sure our data is going to be available. Tip number 5, planning for obsolescence. This is one that I see so many organizations fail at. You have to understand that all models are going to drift or decay over time. And you need to plan for that up front. So, for example, let's say that you've got a model that's going to predict the level of sales in retail in a given year. One of the things that you're going to need to monitor is how many people are going to retail stores in that industry over a given period of time. Because as of today, when you're doing your model, let's say that 40% of an organization's revenue is coming in from retail stores. Well, next month, most people may be shifting more and more over to online sales. Well, the model was very good when you built it based on the data that the model had at that given point in time. But as time changes, the environment changes, the data changes. All those things need to be accounted for. And you can't do that up front because you don't necessarily know how the model is going to decay or how much or over what time. So the trick is to know that any model that you put in place in a given period of time is probably going to decay. So if you follow this set of steps, that was actually created by the ESCML and reported by University of Maryland, you can actually identify how often you're going to check the performance of the model, let's say every quarter, and how much drift are you willing to put up with. And at what point in time are you going to rebuild the model based on data that's refreshed? Plan that on the front end. Make sure that your internal client knows that this is likely to happen and you need to be prepared for it. Don't go into a situation where your client is expecting that everything is going to work just fine and then sort of spring this on them at the end, because they're not going to be very happy. So put into your plan how often are you going to measure, when are you going to update the model, and what is your swap out process. Tip number 6, plan around the analytics maturity model. Now, look, I know everyone and their cousin Sally seems to have an analytics maturity model, but the one I'm going to use is going to be from Gartner. So essentially, an AI maturity model says, what level is your organization in for implementing models? If, for example, you're in a very small company, or you're just working on level 1 awareness, you're just trying to get your organization to understand what artificial intelligence is, or when to use it, when not to use it, all those types of things. They don't know a whole lot. They don't have a whole bunch of models in place. If you're in this level, you do not want to be putting in a model that's really overly sophisticated, or that's going to have one that's going to have a low explainability level. Why? Because it's going to be very hard to get internal buy-in, and there's a high chance that people are going to get confused, they're not going to understand, and they're not going to implement the model correctly. As opposed to, let's say you're on level 5, transformational. You've been putting AI models in forever. AI is considered part of the business DNA. You have a regular schedule for models. You have models in every single department, all sorts of processes. Here, you may be willing to put in a more sophisticated model, or a model that has less direct explainability, because there's a comfort level in the organization. But you need to make sure that you are matching what your implementation complexity is going to be to the level of your organization. In the beginning, you're going to start with simpler models. You're going to start with things like logistic regression. You're going to start with things like decision trees. You're going to want to make sure that there's a high explainability level. You want to get everyone comfortable. You want to get buy-in. That's very different than if you're an organization that's been working on deep learning models for the past decade, and they actually have AI as part of that DNA. Tip number 7, validation overkill. Now, let's all take a step back. This is probably more steps in validation than anyone really needs to have. But the reason why it's set up this way, in 7 steps, is the fact that you want to be building trust. Trust is going to be the currency that allows you to be successful or unsuccessful in your organization. So you want to provide more levels of validation than really ought to be necessary. Not so much that it's going to impact the model, as it is it's going to impact that trust level, and to make sure that the wheels don't come off, so to speak, as you're going into implementation. So here are the 7 stages I recommended for one of the organizations I've worked with. 1, have a holdout sample validation. Break your original data set into a test and a training set. Only build the model in the training set, and then only report results on the test set. This will make sure that the model is not overfitting or essentially memorizing the answers. Step 2, cross-validation. You're going to take, let's say, 5 stripes of your data. 1, 2, 3, 4, 5. And for each one, you're going to have a bunch of green stripes of your data and 1 pink stripe of your data. So in this case, each one of these little blocks represents 20%. You're going to build your model on this 80% of your data, and you're going to test the green, and then you're going to test on the pink one. For your next attempt, you're going to go through and you're going to change which block becomes the test group. This is extremely valuable for preventing the impact of overfitting for your data. Also works extremely well for smaller data sets. It's extremely useful to also combine the results of each of the individual models together and come up with voting on what the correct answer to your model is going to be. So that's cross-validation. 3, holdout time frame validation. This is extremely important if you're doing stuff like time series, but also if you're doing a longitudinal study, let's say over the past 3 years. You're going to want to hold the most recent time period, let's say a quarter, your most recent quarter, and don't make it available in the actual model building period, because you want to see if time elements have shifted things in your data that will change the results of your model. So this is one that you're going to do all the way at the end of the process after you've completed validation steps 1 and 2. 4, silent validation. All this means is you want to make sure that the model on a daily basis can produce a score without doing anything with that score. So for example, you want to make sure that a score is created every day, that you don't have missing records, so you don't have any operational issues, that you're able to read the scores, that it makes sense, that the representation across deciles is the same. Basically, this is your operations check piece here. You do this in silent mode, meaning that you're not showing those results to anyone else. You're making sure that the piping, so to speak, in operations is working so that you don't announce it to the organization and then find out there's a problem and then have egg on your face. Step 5, recruit validation. Who's going to be using this model? For example, if you're going to do your model with a sales team, you may want to take a group of recruits. You want to work with those recruits, find out who's willing to test out the model and see if the results hold up. What are their comments? What are their concerns? You want to make sure that all those are taken care of before you move to stage 6, which is rollout validation. Rollout validation tends to happen right after someone does step 1, a holdout sample validation. And that's where a lot of your implementation, the wheels are going to start to come off and you're going to have big issues that you're going to have to address. You want to make sure that you've taken care of these steps as much as possible. But the rollout validation is going to say in week number 1, let's say of a given month, we're going to roll it out and see what happens. And then we're going to rest the model during week 2, fix anything that's wrong, and then continue the rollout. Step 7, non-stop optimization. This is basically a silly term, but essentially it means you're never done validating your model. Things are going to change over time. This is where you put into the steps that we just talked about in terms of preparing for model drift and that you're going to have to replace the model. Over time, you may continually want to be able to improve the model, test it, update it as needed. Step 8. I have the hardest time with most people getting them to understand and buy into this concept. Simplicity and flexibility are your allies. Complexity sows the seeds of its own destruction. Don't make a model more complex than it has to be. Don't make it harder to understand than it has to be. Don't make it take longer than it has to be, either in development or in scoring the final results. If you have to make a decision and it's unclear what the final impact on the model is going to be, stick with things that are simple and flexible. Step 9, create a champion challenger testing approach. Now, what I mentioned earlier a couple slides ago was you may have a situation where you have to update a model because you've had model drift or some other type of issue. Don't just take the first model and throw it away, stick in the second model and hope for the best. You want to have a process in place called champion challenger, where you have model A, which might be the existing model, and model B, which might be the new model, and you want to compare the results between A and B, which is working better. You may find that the new model that you just built on the new data isn't working as well. You're not going to be able to find this out unless you have scores from both models at the same time. You want to make sure that this is taken care of before you permanently replace any model. Make sure that you're getting results from both models in production before you decide to get rid of the old model. Last, what is your undo plan? So many organizations don't think this through. Always, always, always test your undo plan. don't just have an undo plan. You need to test it. How are you going to get this model back out of production? If you take the model out, are there other processes that happen downstream that are going to be implemented by this? What's going to be the impact of that? You need to be prepared and to test your undo plan before you put anything into production. That's all I have for today. If you have any questions, please let me know, and I'll do my best to answer them for you. Thank you so much.
Wow, that was intense from T. Scott Daniel. So we are ending our webinar in a few minutes, and since we have our speaker Brian Muhia here with us, I'll invite him for just 2 minutes or less to share with us his closing remarks and also a pro tip to all the attendees of our webinar today. Brian, welcome. Brian Muhia, can you hear me?
Hello?
Hello, hi. Hi, Brian.
Hi. Sorry, I was on a call. This session has been really interesting and inspiring. A few takeaways are that the problems that we're experiencing as a community, whatever we're trying to build, are all mediated through some form of accessibility, right? So either it's up to data or up to accessibility to resources, and we can take advantage of some of the things that seemed like disadvantages a few years ago. So, for example, a few years ago, we thought the fact that we would train our models on a data set that we had, right? Let's say you train a model on a public data set. If you're in a production setting, you have access to a lot more data because the data that you actually end up collecting actually reflects the preferences of the users you actually have, right? And figuring out ways to take advantage of that without introducing bias, which is introducing like a particular view, aka labeling of things of data, is the best way. Therefore, every single organization that has collected a massive data cache, especially if it's not annotated in any way, it can still be used, and that's even the best possible option because all of the unlabeled data that we have access to is a reflection of the domain that we are in. So if we are to enable and unlock the value of all of that data, I think it's the best option for us is to figure out how to include semi-supervised or supervised learning in a lot of our techniques, get access to ways to improve our users' privacy so that they can participate even more, right? So using techniques like federated learning, which guarantee their privacy and especially when they're using the systems, to also look into really considering the whole process of software engineering as part of your project, not just looking at the models themselves. Scott's statement was quite accurate. It's not just about the models. Right? It starts with people. It is always about people, which is what software engineering and like product development actually is. So yeah, it looks like we like focused on this very, very different aspects of the same questions. So I'll let Billy continue as well and provide his perspective.
Okay, thank you so much, Brian. Billy, if you can hear me. Billy. Hi, Billy.
Hello. Hello,
Hi.
Lydia.
Hi, we're just giving our closing remarks and maybe
Yes.
a pro tip to our attendees as we finish.
Okay.
In 2 minutes or less.
Okay, so basically, I think I really appreciate the fact that we sort of having this conversation within the AI ML community, global community, and the the contribution of deep learning.ai towards making improving machine learning knowledge quite globally, and also in effect the sort of mentorship from also Andrew, and also I would just like to applaud the participation of all participants who have been here with us and contributing to the questions. Very insightful for the many questions that you've asked. So for me, basically, my pro tip will be now machine learning is always in continuous development. There's a lot of research happening in the industry. So my advice will be just keep on learning, because even learning for us, for me in particularly as a practitioner, never ends. I think we always in a continuous learning loop, and I think the best way is to just make sure you interface with communities, interact with different in different platforms, work on different projects on a consistent basis, and sort of build your skills around that. Now, the knowledge of enterprise ML deployment, and I like the sort of the presentation that Scott has brought forward. It's more of a generic approach. Is more of a very conclusive way of how machine learning is sort of handled within organization, and some of the things we need to look forward to. And I believe as practitioners, we just need to work on ourselves so that we can become those top-notch experts and help pushing enterprise ML within organizations, either within the African ecosystem and even globally. So I wish everyone the best. Take advantage of the deep learning credits that you've received. I mean, this is, for me, this is one of the most important resources that you can get just to keep up and running in regards to some of the machine learning specialization courses that they've offered. And I'll just ask you to take advantage of that and then upskill yourself. Even during this season of Corona, it's the best time basically to upskill. So many thanks, and stay safe. Wish you all the best.
Okay. Thank you so much, Billy and Brian. Reminder that we will be sending all these materials in the coming week. And so without further ado, allow me to welcome Tabitha for a vote of thanks as we finish up. Thank you, guys.
Hi, everybody. Yeah, I'm back again. It's been a really intensive and I believe informative session for all of us. We've been here since morning and it's now 2 p.m. Yeah, Kenyan time. And yeah, I mean, we have come to the close of our webinar session and we've had a couple of questions, many questions from you guys. Some have been answered, some have not yet been answered, but don't you worry, because we'll be able to address these questions. We'll be doing follow-ups. And the good thing is also you've gotten to be able to get some contacts of some of the speakers, like the Twitter handle, so you can easily engage them in conversation. So if you have a question that you need to be answered at a more individual level, then feel free to do so. But we'll also be able to try and handle some of the questions through the emails we'll be sending very soon. Yeah, so thank you so much for staying till this far. So as we move forward, let's cultivate. I believe throughout the whole session, there's something that you've learned. So as we move forward, let's cultivate product development mindsets, build innovative data products and solutions. We are now fully equipped to deliver significant value in production projects and to address complexity and data pipeline concerns in production environment. So we shall be receiving 2 emails next week. One will be a follow-up email with a short survey. We will like to know what you think. Also in line with this, I've activated a poll on the Slido platform where some of you have already started rating, and I can see you're giving a good rating. So yeah, you can still do this even after this whole session is over. So when we send the email with a survey, please provide your feedback on the webinar to help us improve as we move forward and on future activities and engagements. So this email will also be composed of a full recap, blog post, and slide share of resources and materials from our speakers. You guys raised concerns, like some of you wanted to get the materials like the slides. And so yeah, the good thing is we'll be able to be providing this in the emails we'll be sending in the coming week. Secondly, you shall receive an email from the deeplearning.ai team with guidelines on how to redeem the coupon codes for the deeplearning.ai courses on Coursera, including the newly launched AI for medicine specialization. So the most frequently upvoted question was the one of, oh, I came here for the coupon code. How do I get the coupon code and when do I get them? So the good thing and the good news for you guys is that in the second email we'll be sending you guys, you'll be receiving this from the deeplearning.ai team. You'll know and get guidelines on how you can redeem this coupon codes and probably start your way out and yeah, do something productive for yourself. And also don't forget to check out the recording of this webinar and more data science and machine learning content coming up on the YouTube channel. So some of you guys have been watching by YouTube and some on Zoom. But yeah, so you can be able to access the recording of this, which will be published on the YouTube channel, where you will subscribe and get more details from us. Yeah, having said all that, those were basically the announcements. So I'd quickly like to pass in a vote of thanks on behalf of the organizing team for the Deep Learning AI team, the Developer Students Club, University of Nairobi, the Microsoft Student Partner, University of Nairobi. Yeah, we would like to send a big thank you to the speakers, especially the speakers who actually took their time. It's a weekend, the world is in a pandemic, but you found time, whether you're in Kenya, and for those speakers who joined us from other countries that is abroad, thank you so much for finding in time to get to answer questions from curious learners. Yeah, and so this will not be able to come to this far without the organizing team. That is the whole the Microsoft Studio Partner, the Developer Students Club, and the Deep Learning.ai. I mean, all this just possible because of you guys. So a big thank you. We are really, really sorry for the inconveniences we had in the beginning, where we had some misbehaviors. I mean, this should be a lesson to us. Maybe in the future when you have such events, please let us consider being respectful on such platforms so that we can all learn and engage in a conducive environment. So I'm hoping that we have all made best use of this limited opportunity to e-meet, learn, share, e-connect, and have our burning questions answered with this amazing global community of deep learners. Thank you so much, guys, for staying in from morning till this time. We really appreciate you, and this will not have been possible without you. Thank you so much. And with that, it's a goodbye from us. See you next time.